Ladies and gentlemen, I'd like to start by extending the warmest of welcomes to you to this event at the Institut Polytechnique de Paris today. As you know, over the next 2 days, we're going to be looking at what can be described as a groundbreaking summit for a number of reasons. That summit then entitled AI, Science and Society, Connections, Collectives and Collaborations for Good Reason. Now, the event is, of course, dedicated to scientific inquiry and forms part of the AI Action Summit, which many of you know will be taking place in Paris on the 10th and the 11th of February. That, of course, organized by the French government. And at that event, you can expect some high-level discussions, notably with policymakers, innovators, and, of course, industry pioneers, not to forget top researchers who've flown in for that event from all over the world. But back to this event today, AI, Science and Society, this conference then aimed at exploring the life-changing impact of AI, of course in terms of scientific inquiry and technological innovation, but also in terms of the impact on society. So two of the key questions that we'll be running through, or will be a universal thread, if you like, through these 2 days of conferences here at the Institut Polytechnique. How can an AI-driven future meet our societal needs? And of course, what are the drawbacks? Because there are also drawbacks, and we will be fleshing those out with you today and, of course, tomorrow at this key summit. So what can you expect from today and tomorrow? Well, you can expect to gain a better understanding of the cutting-edge technological advances that have been using. You can also expect to hear about research and expertise from top world-renowned specialists who are here, who are ready to share their knowledge, their expertise, their years of experience with you in the domain of AI. Now, how will that take place? Well, we've got a really packed program for you. There'll be keynote speeches, there'll be symposiums, plenaries, and much later on in the day, a fireside chat where we'll hope to, culminate a lot of the questions that have been asked today. So on that note, we invite you to take advantage, enjoy this very unique summit, if you will, a platform where we can look at, how we can move forward with innovation and look at, pioneering for the future. Quick reminder to you today that this conference is supported by High Paris Cluster 2030. That is essentially an AI initiative that's co-founded with IP Paris, HEC Paris, INRIA, and the CNRS. And the aim then is to harness research in both education, artificial intelligence, and let's be honest, bolster France's role in what is an increasingly competitive AI world. So, I'd like to just inform you before we move on that we have two key chairs at our summit today. We have, first of all, Michael Jordan, or Professor Michael Jordan, I should say, of Berkeley University. Welcome to you. And equally, the École Polytechnique's very own Professor Eric Moulin. So as you enjoy the day, you'll get a chance to participate as well. This is an interactive summit. If you do have questions that you'd like to be answered by, once again, our world-renowned experts, please scan the QR code and we'll have a chance to hear some of those questions later on today. Well, listen, just some logistics. You are in the Poincaré Amphitheatre. That will be useful later as we start to disperse you into other areas of the Institut Polytechnique. Can I welcome on stage to formally open our two-day conference, Laura Chaubard. She's president of the École Polytechnique. Welcome to you, Laura.
The things you're into are always changing. The music you listen to, how you spend your time with friends.
Ladies and gentlemen, dear colleagues, dear students, dear friends, welcome to École Polytechnique. It is a great pleasure to welcome you all in this Auditorium Poincaré for the opening of the AI, Science and Society Conference as part of the AI Action Summit. Over the next 2 days, we will have a magnificent program and a unique opportunity to reflect on one of the most transformative forces of our time, artificial intelligence. The summit brings together brilliant minds from research, industry, and policymaking to explore the impact of AI on our world, and I am thrilled to see such an esteemed audience gathered here today. I won't be long, because I'm sure you can't wait for our fabulous plenary speakers to take the stage, but let me tell you an anecdote. Recently, I was meeting with one of our distinguished alumni in Palo Alto, a potential major donor for our school, who has spent 40 years in Silicon Valley working on tech and AI. He had invited me very kindly to his home, and I have to say he had really gone out of his way to make me feel welcome. He had prepared a nice French-style breakfast with fresh croissant, homemade jam, the whole thing. As we sat down, I was expecting to start with some polite conversation, maybe reminisce about his time here at École Polytechnique, but instead, his first words completely caught me off guard. So nice to meet you, Mrs. Chaubard. However, regarding your fundraising efforts, bad timing, I must say, since universities will disappear within 3 years, given the current pace of AI development. This bold and a tiny bit provocative statement reflects the deep transformation we are witnessing. Needless to say that to navigate those transformations, I believe that the world needs more than ever the guiding lights of science and education. But it shows how the spectacular progress of AI is not just about science and technology. It is reshaping the very fabric of our societies. It challenges our relationship with creativity, with knowledge, with work, with learning and teaching, and even with social interaction. Throughout history, humanity has questioned these topics, of course, at the rise of the printing press, during the Industrial Revolution, and at the dawn of the internet, but rarely have we had to confront all these questions simultaneously. And what's more, facing the existential challenge of climate change at exactly the same time, compelling us to reinvent our society entirely from top to bottom. At École Polytechnique, we are no strangers to moments of profound transformation. Our school was founded in 1794 in the midst of a revolution, when France had to reinvent its entire societal model. And at that moment, France made the choice to build the foundation of its new regime on knowledge and science as a way of collective and individual emancipation. Today, as we navigate a new revolution, I believe École Polytechnique and universities all around the world can once again be essential actors to ensure not only innovation, but progress. École Polytechnique has built its reputation on a strong mathematical heritage that already has proven itself very effective to train brilliant minds in AI. And now it stands ready to play its part in the coming years. More than ever, we remain committed to upholding and transmitting the core values of the scientific approach: curiosity, integrity, rigor, and excellence. These principles are essential to ensuring that AI develops in a way that is truly beneficial to society. Before we begin, I would like to take a moment to express my deep gratitude to all of those who made this summit possible. Organizing such an event in kind of a record time is no small feat, and I want to warmly thank the teams of Institut Polytechnique de Paris and École Polytechnique who worked tirelessly to bring us all together today. A special thank to the scientific committee chaired by Professor Michael Jordan for shaping an outstanding program, and of course to Professor Eric Moulin, the man behind the scene, whose dedication and vision have been instrumental in making this event a reality. This summit is an opportunity to foster new ideas, build meaningful collaborations, and engage in a thoughtful debate. I can't wait to listen to all the participants and speakers. Once again, welcome to École Polytechnique. I wish you all an inspiring and productive conference. Thank you.
Can this help fade away dark spots?
Dr. Gundry, can age spots be removed?
Absolutely. Age spots are not actually caused by aging per se. They're not caused by the sun. They're actually a
Well, Laura, thank you very much indeed. I like the way you coined it there, a meeting of brilliant minds. I think we should stick with that today because it's certainly the case for this two-day conference. Can we welcome Thierry Coulon, who is president of the Institut Polytechnique de Paris.
Thank you, Laura, for welcoming us. Ladies and gentlemen, esteemed colleagues, distinguished guests, dear Anne, Monsieur le député, Mesdames et Messieurs les élus, chers collègues, chers amis. It is both an honor and a great pleasure to welcome you today to the École Polytechnique, member school of the Institut Polytechnique de Paris, for this conference dedicated to a subject of immense importance, artificial intelligence. This is not simply a topic of the moment. It is one of the cornerstones of our future. We are living through what is undoubtedly one of the greatest technological revolutions in human history. Artificial intelligence is not merely another tool in our technological arsenal. It represents a profound disruption, transforming the way we think, work, communicate, and even perceive what it means to be human. It holds incredible promise, from revolutionizing healthcare to driving significant gains in energy efficiency, and creating personalized educational tools. However, it also brings with it critical challenges: the risk of bias, the potential loss of control, and the growing dependency on technology. It is a cognitive, scientific, and societal revolution, reshaping the boundaries between humans and machines and redefining the space where automated decision-making meets human responsibility. It's also reshaping how we conduct science, altering our methodologies, accelerating research, and opening new interdisciplinary avenues. This conference today perfectly reflects the scale and complexity of these issues. With over 4,000 registrants, including 60% from the research community, PhD candidates, students, educators, and researchers from across France, particularly from institutions involved in the 9 AI clusters of France 2030, and of course from all over the world. This gathering demonstrates the depth of interest in AI. We are also proud to welcome representatives from nearly 200 companies, including numerous startups, all of which contribute to the vibrant and rapidly growing innovation ecosystem that we are committed to nurturing. At the core of the mission of IP Paris lies the connection between research and innovation. Each year, we support nearly 100 deep tech startups, and it is gratifying to see so many of our alumni thriving in some of the most innovative companies in the AI sector. This conference is also a testament to France's dedication to training a new generation of talents. These young women and men, full of dynamism, creativity, and potential, will lead tomorrow's breakthroughs in AI and technology, driving the transformation of our societies. Artificial intelligence is obviously a global challenge. and France, as a central player in Europe, plays a key role in fostering a global scientific and technological ecosystem. By collaborating with our European partners, we enhance our collective capacity to innovate, regulate, and promote an AI that is ethical, inclusive, and sustainable. It is also with great pride that we recognize the truly international scope of this event. More than 80 nationalities are represented here today, highlighting the global significance of this discussion. We are pleased to welcome representatives from over 15 embassies, alongside representatives from governments all around the world, including the United Kingdom, Spain, Costa Rica, Togo, Belgium, South Korea, Singapore, Canada, the United Arab Emirates, and India, the co-chair nation of next week's AI Action Summit. Furthermore, we are honored to host 3 French ministers during these 2 days, alongside representatives from major international organizations such as the OECD and the United Nations. Their participation underscores the global importance of our collective work, and we thank them for joining us to share their expertise and enrich our discussions. Throughout this conference, we will be hearing from more than 50 distinguished speakers, representing some of the world's leading universities and institutions: MIT, Harvard, Stanford, Oxford, KAIST, TU München, and many others. Their insights will no doubt enrich our understanding and spur new ideas. This gathering is first and foremost a key prelude to the AI Action Summit, scheduled to take place next week at the invitation of the President of the Republic, Emmanuel Macron. I'm happy to welcome his special envoy, Anne Bouvreau. This summit aims to weave artificial intelligence into a global conversation, addressing not just technological and economic challenges, but also the profound ethical and political question it raises. Why, you may ask, is the Institut Polytechnique de Paris the ideal venue for this conference? Because IP Paris is no ordinary institution. It is a unique ecosystem that brings together renowned engineering schools, École Polytechnique, whose Director General Laura Chaubard I thank for hosting this event, ENSTA, École nationale supérieure des techniques avancées, École nationale des ponts et chaussées, École nationale de statistique et administration économique Paris, ENSAE, Télécom Paris et Télécom Sud Paris. Je voudrais remercier les directeurs des écoles qui sont ici présents avec nous. Schools with a long history of training the engineers, researchers, leaders, and innovators who rise to meet the scientific and technological challenge of their time. Artificial intelligence, by its very nature, demands this type of multidisciplinary approach. It lies at the intersection of fundamental sciences, mathematics, statistics, computer science, alongside engineering, advanced technologies, and the humanities. Who better than an institution grounded in scientific excellence and interdisciplinarity to contribute to this endeavor? Yet, AI is not only about technical prowess. It compels us to confront fundamental questions that will be at the heart of the upcoming AI Action Summit. How can we ensure that AI serves the public good? How can we mitigate algorithmic biases and prevent the amplification of inequalities? How can we preserve societal sovereignty in the face of global technological forces? These are the questions we will start exploring together today in the lead-up to next week's summit. The AI revolution represents an unprecedented moment in history, one where mathematics, statistics, and the fundamental sciences impact directly economic shifts, healthcare advancements, global geopolitical dynamics, and our daily lives, and more, all at the same time. This technological disruption is advancing at an extraordinary pace, and it will not slow down. Over the next 2 days, our discussions must serve a greater purpose to inform and support the critical conversations taking place at the AI Action Summit next week. The timing of this scientific conference is no coincidence. It is our responsibility to ensure that world leaders are equipped with the insights and questions emerging from your work, shaping the policies and strategies that will define the future of AI. In closing, I wish to extend my sincere thanks to all our partners, particularly HEC Paris, with whom we co-founded the High Paris Center in 2020, as well as to INRIA, CNRS, and more recently, Université de Technologie de Troyes as part of the AI cluster. I also express my gratitude to the companies that have been supporting us from the beginning and who continue to support us. These collaborations between the public sector and industry will be vital in addressing the challenges ahead. I'm confident that these discussions and exchanges we engage in over the course of this conference will be extremely fruitful, and I look forward to the opportunity to have some highly engaging conversations with you today, tomorrow, and into the future. I'm sure that the next few days will go down in history. Merci beaucoup. Thank you. And I leave the floor to Anne Bouvreau, Special Envoy of the President of the Republic for the AI Summit.
Good morning, everyone. First of all, it's absolutely wonderful to see such a packed amphitheater and all of you here. This is really great. I'd like to thank, first of all, Laura and Thierry for organizing this, and of course, the whole team. As we started planning for the AI Action Summit about a year ago, we came up with this idea, which now is reality, which is that we need to start the conversation with science. And I'm particularly happy to see that it has come to be reality, because of course, the latest developments of AI, which to everyone means large language models and chatbots and things like that, but of course it's broader. These developments, we need to remind everyone that they started in science, and they started with scientific research and new developments. It's also much broader than that, the reason why we need to start with science. Because, of course, large language models, transformers, all the things that you're working on now, they're one of the steps of the development of AI. There will be others. Some of you are already working on them. And it's really important that you continue to do that, and that we don't just think that AI will be forever defined by what we're seeing now. It's also important that we start with science for a number of the areas where science can help us think through this revolution. Science can help understand the impact on work, for example, which is one of the most pressing questions that people have when they think about AI and what it will mean for them. Science can help find solutions and cures in medicine, in health, and that's one of the broadest hopes that people have from AI. Science can help find solutions for the climate change, and there's solutions on the optimization side, optimizing consumption, finding new material for stocking renewable energy, for example. But also the development of AI today is not on a sustainable path. And so we need all of you and more to help us find solutions to have more agile, more efficient, less energy guzzling development of AI, maybe more distributed, certainly more open source. We certainly need solutions on the climate front. Science can also help us understand the societal impacts of AI. I'm particularly happy that the title of those 2 days is AI, Science and Society, because this is such a broad revolution with impacts on societies in plural as a whole, that we need to think through what these transformations mean. What do they mean for education? What do they mean for democracy? What do they mean for information production and quality and verified information? What do they mean, I said, for work, for health, for climate, and I could go on and on. So this is why it's particularly important that you're all here and that we start the AI Action Summit, or the AI Action Week, as it has become, by these Science Days. Let me now tell you a few words about the summit itself. So, well, the summit or the week is starting today, this morning, with you all. We will have today and tomorrow fantastic discussions that I thank you for in advance. We then have at the weekend, and I think it's the first time in the world where we have associated with the summit, cultural events, AI and culture. We will have artists that will be using, that have been using AI for their arts of different kind, and I invite you to come and experiment this. And of course, there will also be roundtable discussions on the way AI changes art and creation. There will be discussions on intellectual property and droit d'auteur, and that's particularly important to remunerate the work that artists do and protect their property. We'll have discussions on information and how AI changes the production of press and media and general information, and information on how this changes the work that artists do and how they do their work. Then on Monday at the Grand Palais is the summit itself. So it's what is an international summit? It is like an international scientific conference, but it's a gathering with heads of states, with CEOs of startups, of large companies, with researchers, and with heads of NGOs and think tanks. So it's really a multi-partite gathering of people coming from more than 100 countries to discuss these various facets of what AI is bringing. So that will be at the newly renovated Grand Palais that everyone has been able to see during the Olympics. And of course, that's one of the reasons why it's easy, or certainly feasible, to invite the whole world to Paris. It's, of course, the quality of the research, of course, the whole ecosystem and the quality of the discussions, but also the magnificent venues that people are able to experiment during their trips. Monday evening, there will be a dinner at the Élysée Palace, but that's really more for heads of states. And then on the Tuesday, there's the closing of the International Summit itself. We're planning a declaration, as typically happens with those events, and quite a number of announcements. And there will be an ecosystem, a business ecosystem day at Station F, one of our largest, our largest incubator in France and one of the largest in Europe. And a number of other side events. There's an event on AI and climate on Tuesday as well. There's AI and the city at École Normale Supérieure. And really, there's 100 events throughout the week, not as big as this one for many of them. But we have a lot of activity, a lot of energy, a lot of dynamism around this topic of AI in Paris and in France over the next few weeks. This is important for the world. This is also particularly important for France and Europe. The recent announcements in a little bit of a battle of titans between the Stargate announcement in the US and then the DeepSeek sort of response, even if it's not a response from China, they show us that the field is still very open in terms of global competition. And there is a route for other countries, France, Europe, countries in the Middle East, in Asia, in Africa, to chart the course of their local, regional AI ecosystems and solutions. What we need for that is talent. We, of course, also need some compute, we need some data, we need a number of things, but first and foremost, we need talent. And I'll probably conclude on this. This is why it's so important that you're all gathered here and that we're launching this week with you all.
You have got to get this Olay body lotion. Never felt my skin this amazing.
What if there was no galaxy far, far away, and there was no joy, and they never did assemble? What if every second didn't count, and he never did remember who he was? What if she never did step into the arena, and he didn't see more butts, and she never did let it go, and no one ever did get murdered in this building? Then that would really suck, wouldn't it? But hey, there is a galaxy far, far away, and there is joy, and they did assemble, and every second does count, and he did remember who he was, and she did step into the arena, and he did see more butts, and she did let it go. And best of all, a whole bunch of people did get murdered in this building.
You gotta be freaking kidding me.
And aren't we lucky for that?
So again, thank you all. Enjoy the 2 days. They will be fantastic. And I'm so proud of you. Thank you.
Anne, I was going to ask you to stay on stage, if you will, if you don't mind coming back up. And thank you, Anne, for putting the spotlight on some of the key questions that we'll be looking at, notably France's role and the wider European role in AI. Can I ask both Laura, Thierry, as well as our chair people for this event, Eric and Mike, to come up on stage for a family photo? Good way to start off. Yeah, family photo. Photo. Our next speaker, many of you will say, doesn't necessarily need a big introduction. Mike Jordan is an internationally renowned scientist in the field of not just artificial intelligence, but also computer science, and statistics. Many of you know Mike as a professor at Berkeley University. You're also, I understand, helping out at the INRA with their kind of new dynamic program called Markets and Machine Learning. If I understand correctly, you'll be chairing that for the next 5 years, Mike. Back in 2016, Mike was named the world's most influential computer science by the very prestigious journal Science. The accolades go on and on, Mike, and perhaps I won't spend as much time on that. What I find really impressive is the number of PhD students over the years that you have supervised. Students who have gone on themselves to make waves in the world AI. Mike Jordan, great to have you with us, and I'll hand it over to you.
All right, it's a pleasure to be here and to kick this off. I hope I will have some slides. Good. I don't think there's ever been an era in human history where a new field of technology has arisen where there was so much hype and hysteria around it. I think maybe electrical engineering came close, electrons were gonna set fire to the world and all. It's amazing to me that data and inference and connections and all that is leading to such hype and hysteria. So I think one of the reasons for that is because we have some technology that's developed, but we also don't have a really good vision of what to use it for. The visions we have are the ones from the 1950s. We haven't updated. The ones from the 1950s, that was McCarthy really imitating a human. How can a computer imitate a human? And there was cybernetics. How do we kind of imitate animals who can, do all these amazing things, climb through trees and stuff like that? That's it. That's our visions. And now we're debating about the implications for that. Are there business models behind that, and so on and so forth. All right, so on this slide, I'm going to propose something which is different, and that word collectivist hopefully will intrigue you what I mean by that. Let me just say up front, it kind of means microeconomics. And, whenever we hear all these fields that are involved and all that, we never hear the word economics. So I hope there's some economists in the room, because you guys got to stand up. It's time to have a role here. That's what's missing. Okay, so here's your standard prehistory that you will see. Here's how it all came about, which is I don't believe, but I'm going to put it up there anyway. Phrase AI was coined in Dartmouth, 1956. They didn't really know what they meant by intelligence, so they didn't define it, but it was something that humans do. All right? Focus was on a single intelligent entity, be that like a human-like entity or a program, but it was this one thing that did this amazing stuff. How do you do that? Now, I don't want to dismiss the excitement of posing such a question and the importance of posing it, the philosophical implications and so on. But it's not really what happened in technology. It's not the case that that event triggered a wave of technological development that we're now seeing, okay? Mostly that triggered programming languages, operating systems. It did a lot for computer science, and it kind of failed mostly otherwise in terms of its goals.
Unlock a new world of efficiency with Asana. Automate workflows so your team can have less follow-up and more follow-through. Try for free today at asana.com.
What happened in the meantime is this field called machine learning arose, mostly not in AI, mostly not with AI people, mostly operations research, statisticians, control theorists, signal processors, and so on. And gradient-based algorithms emerged, and eventually it became all focused on scalability and started to work. Dave Brummelhart there was my advisor. He was one of the developers of backpropagation. He reinvented it, but then he showed it really worked. And his name gets often missed in a lot of these discussions. He should have gotten the Nobel Prize, frankly, because he's the one who made it really happen. And he died young of Pick's disease. It was very sad. The other person I have up there is Leo Breiman, who did random forests. And random forests were a highly scalable architecture, different from neural nets, but had their advantages and disadvantages, gradient-based. They powered Amazon's logistics chains models, which made Amazon into a company that, went everywhere. And they powered many other companies around 1990 through 2000. Okay, so ML deployments were just these big, large bags of data and gradients and architectural stuff. There was no talk of AI. There was no agent. There was no, intelligent. It was just doing stuff. It was engineering, and it really had a huge impact on the world, huge productivity. A lot of companies were based on machine learning starting around 2000. Every company by 2010 was using machine learning in one way or another. No one was calling it AI. Okay, so then came LLMs. Oh my God. It's the same architect. It's bigger, more stuff. It's human language that's coming off the internet. And it looks human, so the phrase AI got retrieved and promoted. And that's led to all this hype and hysteria, the damn phrase AI. If we'd kept calling it machine learning, it would have been a much more sober conversation about what's the business model for that? How do you build it? How do you scale it? How do you make sure it's safe, and so on? All right, now I don't think that LLMs are like the old dream. It's not a single entity, really, an LLM. Okay, it's bringing data from all humans all across the planet. It's like a lot of little experts that kind of respond to little pieces of things. And if a couple of experts agree on something, they thought about it the same way, the machine kind of finds that and uses that as an abstraction. It's all of humanity in there, okay? It's not an intelligent entity sitting on a hill. Okay, now, so the word collective already comes up. LLMs, to me, are a collective entity, all right? But now if we're going to use the word collective, let's recognize that collective is a much bigger word than just bringing together lots of information. Collectives start to open up the door towards economic behavior. Humans, when we come together in collectives, we create markets, we create cultures. We create all kinds of things that just collections of data and nodes in a graph do not do. And that's what I want to focus on today. All right, so we talk a lot about society and social science, and often in ethics, the words are just thrown out there as buzzwords, that we should be more attentive to this society and all that. Economics is a field which is not just buzzwords. It's got real principles about how entities interact to lead to value to everybody, and we're not talking that language. Okay, so more concretely, the dialogue on LLMs to me is missing some fundamental things. There's no focus on collectives whatsoever. It's all about who can build the biggest machine. There's no focus on certainty, or very bad focus on uncertainty. And there's no focus on incentives. Why should people want to play this game? Why should they want to be involved in this whole thing? Just because they're being told to by their boss? And these three things are linked. Okay, so microeconomics talks about all three of them and links them in interesting ways. Now, microeconomics does not solve all the problems. It's got to be refurbished, brought out from its origins, and made more data aware, more learning aware, and so on. It's a huge intellectual agenda for the next 10, 20 years, to me, in doing that. It's a complementary kind of intelligence. When you create a market with a collective, you don't create it. No person designed it. It emerges, and it's happened throughout history all the time. Very interesting, different kind of markets have arisen in very many different kinds of things. That market is an intelligent entity. It brings food into the city of Paris every day, the right amount, not too much, not too little, if it's raining or shining, and whatever the size of Paris over the years. You know, Zola wrote about les Halles, where, you know, the food that comes into Paris and the whole machine that does that. That's an intelligent entity. Now, when you say the phrase AGI, which I particularly hate, is that market and form of AGI? Well, no one talks that language. They seem to imply that AGI is everything, but it doesn't seem to have anything to do with markets, so I don't get it. As you can see, I have opinions. I'm old. Okay, now uncertainty. We have a bunch of statisticians in the room. I really am a statistician, just to say, number one. That's, to me, the mother field. That's where it all, how do we know what's in the world? Okay, statistics. All right, if you ask ChatGPT, how sure are you about what you just wrote, it will say something, and I think I've tried it a bunch of times. It'll say, yeah, I'm very, very sure, and here's why, and blah, 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 blah. And you'll say, but wait a minute, there's this other way to think, and it'll say, oh yeah, that's right, and it changes its mind completely. Now it's very sure about something else, all right? It's almost always very, very sure. Okay, it's not doing uncertainty, reasoning, quantification at all. What it's doing is taking some stuff from the past where someone asked, how sure are you? And there was a response, and it's kind of using that. All right? You would not want a doctor that once they give you a diagnosis, and then you say, but what about this? They change completely their opinion. Okay? It's not doing uncertainty. Now, uncertainty goes together with markets, all right? And so we want to kind of think about this. So how do we cope? How do humans cope with uncertainty? I'm running out. I need a little water. stare at that picture. Okay, so what's going to happen in the future? We don't know, and it's really amazing how much uncertainty there is in our lives. Really amazing. We are not just sitting there reasoning our way through like math problems. We are living in the world of uncertainty. I don't know what's going to happen to me later today, tomorrow, next year, there's all kinds of things. But we do well somehow. All right, now in statistics, we know how to talk about some amount of uncertainty. You know, you've got that data that implies that there's this, you know, error bar and so on and so forth. But uncertainty is much broader than that. Uncertainty has to do with what you know that I don't know, and how much, you know, when we're in groups of people, where is the uncertainty? It also has to do with provenance. Did that data point come from yesterday or last year or 10 years ago? If it came from 10 years ago, there should be more uncertainty from the timing of the data. There's all kinds of issues and uncertainty. There will be a talk, a plenary by Manuel Candes later this morning. He is, like me, a statistician, very interested in uncertainty, and I'd encourage you to attend that talk. Now, I would argue that individual humans are not so good at coping with uncertainty just by themselves. You put us on a desert island, you know, we kind of make a mess of things. But when you put us in collectives, right, we're really good. And so if I don't know how long it takes to get from here to INRIA, which is on Rue Barreau, I can ask, let's see, Eric Moulin, he knows, he used to work there. So I ask him and I get a good estimate. We do this all the time among each other. We don't know something, we ask somebody, they give us an answer. We can tell by the way they answer the question how sure they are. We infer things. We build cultures that mitigate uncertainty. It's one of the things we do really, really well, so that we can start to build and plan and feel good. All right, so collectives are really important. Now, collectives also provide context by what we mean by uncertainty. Here's a duck who's a statistician. The duck has gotten a very good estimate that on the left side of this lake, there's a certain amount of food to be had. On average, you know, that amount of food. And on the right, maybe a little less, okay? And the duck has got nice quantified conformal prediction error bars on this, and then, you know, duck is kind of ready to make a decision now. So should the duck go to the left side of the lake today or to the right side of the lake? All right? Well, the optimal Bayesian decision, so the Bayesian duck would go left. All right, because there's more food to be had there. The Bayesian duck says, where do I maximize my utility? Well, it's to go left. All right? Now, if you do experiments with this, ducks don't do that. Ducks are not Bayesian. Ducks probability match. They see, oh, I see there's 2/3 as much food on the left as 1/3 on the right. Therefore, what I'm going to do is 2/3 of the time I'm going to go to the left, and 1/3 of the time I'll go to the right. That's not optimal from a Bayesian point of view. I can prove that. Right, but they do it. Moreover, humans aren't Bayesian either. They probability match. And there's been tons of articles in, you know, cognitive science about how humans are terrible decision makers because they're not Bayesian. Okay? But the framing is wrong here. Okay? What if there are many ducks? Okay? What if there's a collective of ducks? Right? Now, that's a different problem. It's more of an economics problem. What should any individual duck do? All right, well, I could have a top-down regulatory government framework that says that 2/3 of the ducks should go there and 1/3 should go there, and everybody will be happy, and that's probably what's going to happen in Europe. Or I could just have a little algorithm where each duck randomly decides with probability 2/3 to go there and 1/3 to go there. Distributed, decentralized algorithm. Chaos will ensue, right? No, it's a Nash equilibrium. It'll be highest maximal social welfare. So it's actually optimal to probability match in a situation like this. So the collective also determines what do you mean by uncertainty and what do you mean by decision making. So if we don't talk about collectives, we're missing out altogether on this stuff. If you put a LLM there who's making an optimal quote unquote decision based on uncertainty, you got to say, wait a minute, what's the context? Okay. So I want to start thinking about a vision of, let's call it AI, which I hate to do, but I'll do it because Jan LeCun's in the room. Sorry, Jan, I like to tease him. I want to have one where information flows between entities of a collective. Now, I don't want just this kind of notion of a graph where I have a node and there's a certain amount of data there and it flows. It's just like Internet of Things or something. I want to recognize that these entities possess knowledge and they may or may not want to share it. They may have competitive advantage. I want to think more about these as asymmetries in information flows in an economic setting, okay? So asymmetries of information are critical in economics. If I'm working with someone, why am I working with them? Well, they know how to do something I don't know how to do, all right? And so they know something I don't know. And so if we start talking about how we get a price, how much money will I give you? Well, I don't know enough to tell them the best price because they know something I don't know. They're not going to just tell me, they'll lie. So economics is full of mechanisms that allow you to make progress in that situation where everybody gets something good out of it. Okay, that's called asymmetry of information. To me, that's another kind of uncertainty.
This is the Emirates Premium Economy seat. Economy. Perhaps they need to call it something else.
From Tide, the #1 brand used by dermatologists. No irritating residues, no dyes, no perfumes.
Okay, if I'm working with you and you know something I don't know, I'm uncertain about something. And that's not statistical uncertainty. That's not going to go away at the rate 1 over square root of n. Okay? All right, so these things are all linked up. We want to use our technology now, this burgeoning technology, not just to build LLMs on a hill with all this power usage, but we want to connect people. And we want to connect people with machines. And we want to connect things that give value to people and to entities. All right? But if we just connect things, we'll do what Facebook did. We'll connect things and make us a mess. Sorry again, Jan, but nonetheless, I got to say that. All right? Why do people want to connect? And what prevents them from lying? Well, nothing prevents from them lying. I think there's some lying going on Facebook. I'm not sure about this, but I think there's a little bit of lying going on. Okay? So we need something more sophisticated than just connect things up and make predictions. We need some more statistics and we need some more economics. All right, so just one last slide on kind of, provocative statements here. But here's what I think Sam Altman has in mind, or Elon Musk or whatever, is I take all of humanity's knowledge that they're producing on the internet that I just take for free, grab it, and I create this super AGI thing that can answer any question. It knows everything, right? And so humanity's saved because we can ask about how do I solve climate change, or how do I get to the Roubaix very fast, or whatever question I want, and it'll tell me. Now, we'll spend huge billions and trillions of dollars to get that thing, but once we have it, we've saved humanity. All right, this is nonsense. This is nonsense. I don't want something up there telling me what to do. It doesn't know my current situation, doesn't know my current context, doesn't know what I might want in the moment. I want to be like in a market where I get to kind of look around and think and interact and be a human being. And I want these machines to be in the market too, because they'll know some things I don't know. I'll be happy to interact with machines, but they got to kind of talk some of my language, uncertainty, information, asymmetries, and so on and so forth. So I want it all embedded in there. Okay? So I really think this model of, build the biggest thing on the hill that knows everything is not feasible. It's going to ruin us. And second, it can't know everything. Because what's in my mind right now is the context of what I'm going to do next today in life. It cannot know that. And if it doesn't know that, it can't give me good advice. And I think it's this advertising model where these companies thought they could know everything because they've seen our entire browsing history. And they could predict really, really well. And therefore, let's build AI that just predicts, and it'll tell us what to do. Okay. All right, so I want to do something different. So I want more of an economics model, and I want to do that in the context of markets. So to me, markets are a good word. In some environments, markets are viewed as capitalists. I've kind of gotten questions about, wait a minute, don't markets ruin the world? What are you trying to do here? I think markets are good. Well, they've arisen throughout history, many cultures, many times. They're how humans interact. They reduce uncertainty. So just like Zola talked about, the market that brings food into Paris, somehow someone says, I got some tomatoes. Over there are not enough tomatoes. I'm going to take my tomatoes over there, charge maybe a little higher price, and tomatoes will be available. Everybody does something like that every day. And now I can guarantee there'll be tomatoes most days in most places. Why is that good? Well, because if I'm a pizza owner now, I can have a pizzeria. Because I can guarantee I can find them tomatoes any day of the week. All right? And then if I can have a pizzeria, I can have something else on top of that. I can have something else on that. Things can emerge. If you can build stability, uncertainty is mitigated by markets. All right? Prediction becomes easier when you have markets, all right? Now, markets have to be regulated. So this is the obvious question. Oh, you like markets? That's great. But don't they, spin out of control? Don't you get monopolies? And all? Well, yeah, sometimes monopolies are good, actually, not so necessarily. But, things can spin out of control, and they do. So you want to regulate them. I'm a total yes, we need to regulate them. But you don't regulate the individual algorithm, the individual mechanism. You will create unintended consequences, no doubt about it. You regulate the equilibria of the system. And to find the equilibria, you've got to be more like an economist and study what are the equilibria and how do they change. So I'm going to give examples of that. Okay, so I've been involved in a company for about 10 years now called United Masters. The CEO is a friend of mine, Steve Stout down there. He's a legendary hip-hop producer in the United States. Everyone knows him. And this is a three-way market. So you don't usually study three-way matching market. You don't really study this in economics very much, but so what it is that there are lots of young people, 16 to 25-year-olds, who create music on their laptops, and they're really good at it. And they put it up on the internet, and that's the music that other young kids listen to. So 90% of the songs that are being listened to every day, at least in the US, 90% are songs you never heard of, the artists you've never heard of, and they were written in the last 6 months.
Incoming dishes! Dawn Power Wash flies through 99% of grease in half the time. The better grease getter.
Hold and hydration, made for every texture and style. Flex, scrunch, freeze. Aussie.
So it sounds like great, a thriving market exists. No, they're not making any money. No money is being exchanged. Everybody takes everything for free. And a few big companies find a way to make some money off of subscriptions. All right, so this is a different model. What it does is we've got musicians here who are making music. We've got listeners sitting over there as another side, leg of the triangle. And now critically, there are brands involved here. Brands have money and they have goals. All right, so in particular, the NBA has signed on with United Masters. What's that mean? If you go to the NBA website and you watch a little clip, often there's music behind it, okay? And it used to be that the NBA paid Beyonce or whatever a vast sum of money for that music. Now they go to the United Masters and they say, give me some music. United Masters is a very good recommendation system. They can say, oh, for that kind of purpose, that kind of audience and demographic, here's a good kind of music. They stream it. The musician gets paid in that moment, all right? Then there's other brands involved as well. They watch all of this, it's an open market, and they say, oh, that artist seems to be popular on the NBA website. That's my demographic. I'm gonna reach out to that artist and work with them too. This has been now happening for 5 years. There are 3 million musicians who are making money off of this platform right now. Okay, this is an up and running company that is really, really working. And it is getting people paid for creative acts. All right, and it's critical that it's a three-way market. If it's a two-way market, you got something more like Spotify, which is that some artists make some music, it gets streamed out there, and where's the money come from? There are no brands, there's no one willing to pay anything. Well, okay, I'll try to make a little money with subscriptions and I'll throw a little bit of change back at these few artists. It's not a real market, okay? And so that doesn't work, and moreover, that incentivizes Spotify to get rid of those artists. Why don't I put Gen AI in there to make the music? Because I can get that for free. It incentivizes that kind of activity. It's damaging to the human species. Three-way markets actually really help. They are a good platform for starting to build this. Now, where's the AI in all that? Well, behind the scenes, so I was involved in this, in designing this system. There's a great deal of data flow. It's a matching market with adaptive, who listened to what and what kind of music is it. There's also market design principles. There's mechanism design here. Okay? There's contract theory and mechanism design brought together with machine learning, and it just works. All right. I think there's lots of companies that you could do this throughout the world. It's not being done in Europe that I'm aware of. You could do this with print journalism and not just music or in other kinds of art. There's all kinds of new markets which you can start to think about creating if you think about AI in this way, instead of put all the knowledge in a big super AGI and somehow money is a consideration only for the wealthy. All right, let me just say, I really want to emphasize this. Money is going to 16-year-olds here who do have a creative act. And that money is being given to them not just because some rich person just throws it at them, it's because they're being incentivized in a market to pay. There's all kinds of other markets you can start to think about if you put your mind to it that really haven't been studied in economics, but machine learning drives you to study them. So 3-layer data markets. This is work with Ali Reza Falah, postdoc with me, and who was with ASU, Ostaglar, who's here. So here's a system we were studying where there's users, platforms, and data buyers. All right, so users are people like you and me. We come in, like say to the, to a credit card platform. We want to get a service, which is financial service. So by using the service, data flows to them. They get the data, they improve their models, and I get a better service. That's kind of nice, right? But it's often the case that those companies don't make enough money off of the service, the little fee they charge. A lot of downward pressure on that. So what they then do is take the data and they sell that to third-party buyers. This happens all the time. There's nothing wrong or weird about this. It happens all the time. Now, why do the data buyers buy the data? They're not trying to compete with building better models, compete with the platforms. What they want is to use the data to do like market research. I want to have a new Thai restaurant in the 13th arrondissement. Let's look at what kind of data, what are people talking about, what's missing for restaurants, so I can buy data and learn about that. And it happens all the time. All right, now, you got to say though, but what are the users, don't the users have a little concern about this? They're losing privacy. Their data is getting shipped off to some anonymous third-party buyer. They've lost something. Maybe they don't want to play this game. Why should they do it? Okay, that's a perfectly good question. You can't just assume they're going to do it. So we got to think about the incentives. All right, and so here's the way to think about this without erasure, is that the platforms have got to give some kind of guarantee of privacy, okay? And what's that mean? Well, we have differential privacy. It's a pretty good framework. So they can do differential privacy, which adds some control about a noise to the data. And different platforms can decide how much privacy they will offer. It's part of their service. So I'm going to offer you, you work with me, I'm going to add a lot of noise to the data before I send it to the data buyer. So your privacy with differential privacy is very, very high. I look at that and say, great, I'm going to work with you. Okay? That means that that platform gets more data than the other platform. That means it can build even a better service. There's a little virtuous circle there. But the data buyer looks at that platform and says, wait a minute, you're adding a lot of noise to the data. That's crappy data. I can't do statistics with that. I'm not going to work with you, I'm going to work with this other guy. And so you can see there's trade-offs. And all you got to do as a good machine learning economist person is write down a bunch of equations that have all those trade-offs in them, write down the utilities, find the equilibria, and study the equilibria.
We found love in a hopeless place. We found love in an open space.
This feels totally different to anything we've tried before. This AI is so easy. It doesn't even need a prompt. Finally, reports in minutes. Just look at that beauty.
No way! We found love in an
Monday.com, the first work platform you'll love to use.
Marco!
When you'd rather enjoy the pool than clean someone else's.
Sweetie, get out of the pool.
It matters where you stay. Conrad Hotels and Resorts. Hilton for the stay.
So that's what we do in a sequence of papers, not only this one. And I decided not to, in this talk, get into the details of the equilibria. But let me just say that behind the scenes, there's something of the theory of incentives happening here. We have asymmetry of information. Somebody knows something that someone else doesn't know, how much they're willing to pay for something. And so you can't price things if you don't really know how much they're willing to pay. You kind of have to guess or run an auction. And the theory of incentives does things like business class, economy class fares. It says, I don't know how much you're willing to pay, but I'm going to give a sequence of options, and each one of them will have a different kind of service and have a different price. And then you get to choose. And everybody gets the same menu. And if I design the menu well, it'll kind of cover most of the willingness to pay. And I'll get a few people paying a lot, a few people paying less. The airplane will be full and all. And this saved the airlines in the 1980s. The airlines were about to governments were propping them up. But this contract theory came along and saved the airlines by having these different kinds of fares and so on and so forth. Okay, so this sounds interesting. This sounds like it's relevant to the problems we're talking about. So now we're going to have to talk about our nodes as being things like principals and agents. That's the language used here. The principal wants to do something. The agent knows how to do it, and they need to interact, and there's asymmetry of information. The agent knows something the principal doesn't know. So we have this uncertainty to manage in our network. All right, and there are algorithms. There's a beautiful book by Lafont and Martimore, written quite a long time ago in France, about many kinds of mechanisms that'll kind of, how do you design that menu? Now, what's missing in economics, almost always is, in microeconomics, there's no data, there's no learning. You design the system, you put it out there, and you're done. So all of statistics is not being used. There is statistics meets economics. That's called econometrics. That's more about measuring time series and more for macroeconomics. But in microeconomics, precious little. Okay, so we modeled this. We wrote down a bunch of equations, a bunch of statistics equations, and a bunch of economics equations. Data is now a good and a service. It's not just bits on a wire. It has an economic value. And entities could be both a principal and an agent. The platforms are both principals and agents. So we have a hierarchy now of principals and agents, not just this classical principal-agent paradigm. We built a model, and I'm not going to get into the details here. And now this turns out to be what's called a generalized Stackelberg game. Just a little game theory came in. The platforms make a decision about what services, how much differential privacy. User decides which platform. Platform decides the price to charge to the data buyer. Buyer decides where to price, blah, 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 blah. Okay, so now you can do that mathematically, and you can get equilibria that are functions of all of the parameters, like a utility of how much I care about this, how much do I care about that. And you can make little plots of that parameter, here's the revenue, here's so on and so forth. And those are the kind of plots you could show to a government official, and they will understand them. And that's what economists do in other fields. They make little simple parameters and then the behavior. We could do that with this really complicated learning system and actually now drive regulatory thinking at the right level, which is the level of the equilibria. Okay, so we did that in this paper. We actually showed how there's trade-off between the amount of privacy you offer and the various aspects of the market behavior. And we were able to show there's a way to get higher user utility than just kind of blindly insisting that you don't send data or that you add a certain level of noise to everything. And I think the GDPR is just kind of blind. It was not designed with economic thinking in mind. And the GDPR is known to actually hurt small to medium businesses, okay? And the mechanism we're proposing here would not, okay? I won't say it's gonna fix all problems, but it is based on economic thinking. Last little part before I finish, I'm gonna dig a little bit more into contract theory. So remember airlines, business class, economy class, and so on. This is work with colleagues Stephen, Michael, and Jake. And we're going to bring statistics into economics now in a real fundamental way. So the statistics is going to bring the control of errors in an uncertain environment, and the economics is going to bring the incentives. If you put two together, you can start to solve some real problems. Here's a real problem. Clinical trials are run in every country at vast cost, millions and millions, tens of millions of euros or dollars for all these therapeutic areas. Clinical trial is that I go get 15,000 people and give them the drug, and 15,000 people don't get the drug, and I do it randomly, and then I compare and see if the drug works. It costs a lot of money to do those kind of things. If you don't do the clinical trial, you're gonna do bad science and do bad medicine. All right, so we think about this. This is not the way the FDA thinks about this. FDA is the American regulatory agency. We think of this as a principal agent problem. The FDA is a principal that only has partial knowledge. Here's a new drug being proposed. I can look at that protein and say, well, maybe that'll act on this kind of, cell, maybe that'll help. I can guess, but I don't know very much. And I'd like to decide whether it goes to market or not. So I have to do a clinical trial if I'm the FDA. All right, and what's the FDA trying to do? Well, they're trying to be a good statistician. They want to control statistical errors. False positives and false negatives. False positive is I put a bad drug on the market. That would be bad. False negatives, I failed to put a good drug on the market. That would be bad. FDA is very good at trying to control those errors. They're statisticians. But the problem is that the proposed hypotheses they're getting, here's a good protein to look at, is not just coming out of nature or out of science, it's coming from self-interested agents, which are the pharmaceutical companies, all right? And the pharmaceutical companies know things about whether the protein is likely to work or not that they don't tell the FDA. All right, so now, if the pharmaceutical company knows the FDA is using some statistical procedure to control errors, it can game the system.
With the help of Xero's small business accounting software, I've got the right information at my fingertips.
So business is a breeze. And I've got bigger plans. Search Xero with an X.
Why would anyone keep on running in this weather? Because there's nowhere else you'd rather be. Raise your bar with our delicious energy-sustaining Cliff Bar.
It can say, oh, given that procedure, I'm going to use my internal knowledge to decide that this set of proteins I'm going to go ahead and send in, because there's a chance that even if they don't really work, they'll pass the false positive barrier and they'll get onto market at least for a year or two until everybody realizes they're no good. And companies do this all the time. Okay? All right, so I have a slide here which I'm going to skip, but for want of time. But here's an actual, some numbers that show you how pharmaceutical companies can game the system. And so the top part of it is the statisticians, Neyman Pearson testing, doing it right, controlling errors. And the bottom part is the economics, which is that if a small profit is to be made, the CEO can reason in one way, and if a large profit is to be made, the CEO can reason in a different way, and she can figure out whether I should incentivize my people to send in lots of proteins or not so many. And in the one case, she will lose money if she does it wrong, so she doesn't. In the other case, she'll just make money for free because the false positive rate is low enough that she could just send things in. So you can game the system, just a long story short. And this happens all the time. There are plenty of drugs on the market which are not effective. So we have a new theory. We call it statistical contract theory. Again, I won't get into details here, but I just want to show you a little algorithm. This is a contract in contract theory. An agent, which is now a pharmaceutical company, is given an opt-in protocol. If you want to send in a drug candidate, you either can walk away when you look at this protocol, or you can pay a reservation price R, like $2 million, and now you get to choose a payout function from a menu of payout functions. Payout functions are like licensing terms, how long you can do it for, what kind of strata, all the details. Now, it's like business class, economy class. I can look at that and I say, well, that one is good for me because I happen to know that my protein's actually pretty good and very likely to pass. So I'm going to take a little risk and go for those licensing terms. And some other company says, I don't know much about my protein, I'll take a different one. So we have now mechanisms for designing that menu. And I'm going to show a theorem, because this is a science conference, and I was told we could actually show a theorem. We have a theorem which says that a contract is incentive aligned, okay? Meaning that the right thing to do is to send in the good drugs, not the bad drugs. So a contract is incentive aligned if all the payoff functions are what are called E-values. If you know about P-values from statistics, those are tail probabilities under the null distribution, and E-values are non-negative super martingales under the null distribution. So it's a different way to quantify uncertainty, and it turns out if and only if, contract theory is incentive aligned if and only if the statistics part is using non-negative super martingales. Okay, I'm going to finish with 2 slides. Okay, so here is jumping up 5 levels. Okay, my personal view on this whole AI thing is that it's not AGI, it's not finding, the secrets of human intelligence. That'll happen someday. I don't say it won't. But humans are way smarter than our machines right now, just way smarter. Okay, I mean, they're smarter in some ways. Like a computer can already calculate all the digits of pi. I can't do that, all right? But there are ways that we are smarter, and we will be for quite some time. All right, so what's really happening is there's a new engineering field emerging, like civil engineering, like electrical, like mechanical. Every 50 years, there's a new field that emerges. It's an engineering field. This engineering field, different from all the previous ones, has humans as part of the engineering thing, okay? Civil engineering, not so much. Electrical engineering, not so much. This field does. So it has human decisions and data and flows on networks. Those are the ingredients of the engineering field. And what is the goals of the engineering field? Well, to solve science problems, yeah, sort of, but also just to build good transportation systems, to bring good health care, to solve climate problems, just to make all of our 7 billion people on this planet actually have a good life. That's the goal of this engineering field. And to make education better and make it more interesting art possible, and all those great things that humans can do if they're augmented with these kind of systems. All right, so I think it's really interesting, emerging field. It builds on ideas from inference. It builds on ideas from algorithms. It builds on ideas from economics from 3 centuries, all right? But it doesn't just flow exactly from them, kind of in the way that, like, chemical engineering flows from quantum chemistry. There's a little bit more of a gap. So we're kind of making it up more as we go along. But I think this whole development of this wonderful engineering field is really being held back by this old AI aspirations build a super robot that takes over or helps you for all your tasks at home and all these kind of things. All right, so just last slide, that was all about kind of the, what is this technology and what's it mean for society and all that. But as academics, and I am an academic and always will be, it really is critical to recognize this isn't just computer science. Okay, I've been in the room talking about AI lots and lots of times, and even like AI and regulation. And I ask, how many people are computer scientists? Well, half are computer scientists. How many people are lawyers? The other half. How many people are economists? Nobody. All right, that's just dead wrong. And so these three ways of thinking, let's not even call them fields, but computer science is kind of algorithmic thinking. Statistics is inferential thinking, very different kind of thinking. And economics is incentive-based thinking. And interestingly, these fields have come together in a pairwise way over the last 20 or 30 years. Statistics meets computer science. That's exactly what machine learning is. Okay, in the best version of machine learning. All right. Statistics meets computer science, that's machine learning. Machine learning doesn't have much economics in it, as I've been stressing. Statistics meets economics, that's econometrics. But that's mostly about analyzing time series and helping macroeconomists. Okay? Not much algorithmic mechanism kind of stuff in econometrics. Economics meets computer science, that's a field too. It's called algorithmic game theory. It helps design new kinds of combinatorial auctions and so on and so forth. It has no statistics in it. It doesn't learn. You don't get learning auctions. All right? And the point about it is that green place is the place to be. So if you're at a real company designing real systems that really use data and make decisions for large numbers of people, you will be in the green area. You'll be in the middle. You'll be using all these ideas in a blend. And the students in the room learn all three of those fields and then endeavor to work in the middle in the green area. Thank you.
For the ones who know safety isn't a catchphrase, it's a culture. And the ones who help make sure everyone makes it home safe. For the safety-minded who watch everyone's backs, Grainger offers supplies and solutions for every industry, as well as safety assessments and training to keep your facilities safe and your people safer. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Mike, thanks very much for a really thought-provoking key address. Just to say, we'll get a chance to listen to more of your kind of personal view on AI a little bit later in our fireside chat. Yann Lequin, you'll have a chance at a droit de réponse. You'll be able to respond to some of those provocative comments on Facebook from Mike there. That keynote address then takes us quite nicely into the first plenaries of the day, and perhaps one of the first difficult decisions that many of you are going to have to make. We're going to have plenaries taking place simultaneously. So in the Arago Amphitheatre, which is just below our amphitheatre, you'll have the opportunity to listen to the statistician that Mike just made reference to. You'll be listening to Emmanuel Candès, who is the Barnum-Simons Chair in Mathematics and Statistics at Stanford University. After Emmanuel, you can also hear from Asuman Ozgladar, who is a Mathwork Professor of Electrical Engineering and at the College of Computing, MIT. I can see lots of you making your way there. Good, you've revised the program. That talk with Emmanuel Candès and, of course, Asuman Ozgladar will take place in the Arago Amphitheatre. Here, in the Poincaré Amphitheatre, we'll be welcoming Professor Eric Xing to the stage. And Eric is president of the Mohammed bin Zayed University of Artificial Intelligence. That is the first artificial intelligence university in the world. He's also professor of computer science at the Carnegie Mellon University and co-founder and chief scientist at the Gen Bio AI. So what I propose we do is give a few of you just a couple of minutes to choose which amphitheatre you're going to be in, either here in the Poincaré or also in the Arago. And we will start our first plenary here in the Poincaré with Eric Xing once the movements have been made.
If you love iPhone, you'll love Apple Card. It comes with the privacy and security you expect from Apple. Plus, you earn up to 3% daily cash back on every purchase, which can automatically earn interest when you open a high-yield savings account through Apple Card. Apply for Apple Card in the Wallet app. Subject to credit approval, savings is available to Apple Card owners subject to eligibility. Apple Card and Savings by Goldman Sachs Bank USA, Salt Lake City branch. Member FDIC. Terms and more at applecard.com.
J'entends rien. Est-ce qu'il peut allumer? Ah, super, c'est là. Okay. Ladies and gentlemen, just a couple more minutes for you to take your seats here in the Poincaré Amphitheatre. Good to see that it's such a full house, ultimately.
Mix, match, more happy with Gain.
A computer later as well.
No, I give up on all the movies and everything. I'll just have a PDF, and that way there's no.
Okay.
No risk.
Which is not working, I think. I think we will play the video on like YouTube.
Just one more minute to allow you to find your seats. How are we looking, Eric? Looking good?
Should be good, yeah.
Oh, well, as we were saying to you a short time ago, Eric Jing is, or Professor Eric Jing is president of the Mohammed bin Zayed University, which of course is the first artificial intelligence university, you might say. Of course, there have been others that have been started up since, but one university really focused on AI. A key focus for Eric is problem solving around automated learning, reasoning, decision-making, particularly in diverse social systems. Eric has served on a number of boards for leading scientific journals, including the Journal of the American Statistical Association. Eric, if it's okay with you, handing it over.
Thank you very much. All right. I will be waiting for my slides to be on. I did some last-minute changes, so tried to use my own laptop, but it didn't work. Now it worked. So first of all, it's a great honor to be here to speak to such a spectacular audience. I didn't realize that there are two parallel tracks because I wanted to be hearing also Emmanuel's own presentation, but I will do my best to make sure that this room is equally entertained. So, as the previous moderator introduced Mike, he produced many graduate students. In fact, I am among one of his graduate students many years ago. It's always intimidating for him to speak after him because he always dives so deeply into the technical content, which makes a good foundation for me to roll out my presentation. I will be stepping a few stories higher to give you maybe a more broader view about what's AI and what is going on in the whole field. In fact, another speech from President Laha was also very interesting. She mentioned about a comment where university may disappear in 3 years with new AI. I took it a slightly different way. I think indeed there needs to be a lot of change in modern universities in light of modern AI, and it encourages you to actually rethink how to reprogram university. And that's exactly what I did in the past few years. So I want to take this chance to also say a few words about a new project I have been doing, which is to create a brand new university of artificial intelligence in a young country called the UAE. Right, so this is what I've been working with, in the past 4 years. I went to Abu Dhabi in UAE to be the first president of this university called Mohammed bin Zayed University of AI. It is established exactly 5 years ago, and it is meant to be a graduate school, for AI research and innovation. And over the past 4 or 5 years, we actually made tremendous progress in thinking how to create a sensible modern program in AI and beyond that, and also how to build on the success or maybe lessons to do even better. And here is a quick word about where we are right now. Right now, this university has been really doing very, very actively in expanding. We actually went through a very, very aggressive path of expansion in the past 4 years. You can see this growth rate, which we kept above 50% every year. And as of now, all the disciplines we covered, which includes 8 departments in different areas of AI, collectively ranked top 10 in the world. And we published, of course, thousands of papers. And we graduated hundreds of students, many of them stayed in the UAE. And we even roll out many startups and train many government and the private sector leaders. But this university is unique in that it is not about just education and the basic research. We are almost also like an industry where large foundation models, modern AI infrastructures were deployed and utilized and explored and pushed further. And here are just a list of some of these projects. You can see we produced actually the largest and the best Arabic natural language models. And also we've been developing models for biology, for the world model, and many other things. I think that's probably an interesting new approach to modern university where you want to bridge the gap between university and the private sector to make them more agile and also more resourceful in terms of how large-scale modern science in AI can be carried out. Otherwise, university indeed will stay out of the game and become less and less relevant with the fast advancement of AI. And through that effort, we were able to really push UAE to the frontier of global AI competition. One of the rankings published in Stanford last year actually put UAE now among top 5 of the AI power countries. And I believe our university made some positive impact in that ranking. In the next couple of years, we are going to continue to grow, but not only in the space of AI. As Mike mentioned, AI is, in fact, many years ago, we don't even call ourselves AI. We call ourselves statistical machine learning and other things, which means that it is a very, very profound and this interdisciplinary field, which can enable a lot of other topics. And as a university, we cannot just solely rely on a very narrow band of innovation. And our plan is to add both breadth and depth into the offering and also into our activity. For example, in the next 5 years, we're going to add 2 new colleges in public health and in decision science. And after that, we'll be adding back the arts and sciences and also the engineering, but in a way that is different from the way we did or people do nowadays, because these are a vision, as mentioned, coming from the 50s. And now with the AI, which provides you encyclopedic knowledge right next to your fingertip, how can you rethink about the skill? How do you rethink about innovation? And doing your job can be very different, right? So we want to make sure that our education and the university infrastructure are prepared, maybe even stay ahead of the game to get trainees ready for their job. So with that, I hope I set a stage, for the talk, because the technical material that I'm going to present actually came from our work from this very university, which was actually not quite so possible, elsewhere in the world, in the traditional school, because of resource limitation, because the traditional incentivization mechanisms in university, which counts papers, or counts other things. And here, we're thinking about or talking about how to maximize the impact of AI and how to execute even faster. Right. So just a quick recap. What is happening now, in the AI world? Well, this is happening. Last year, we got this great, a boost, in our field, which is that, our foundational work and our applicational impacts gets recognized, by, honors, as prestigious as a Nobel Prize. And that actual announcement come right in the middle of my own presentation in a workshop promoting, AI applications in biology. So it was very, very exciting when we heard that news. And not only it is recognized in the AI field, it is also widely recognized in the general public. You see now a wide spectrum of applications of generative AI and large models across the field, in language, in image and video, and in science. People are talking about, maybe the whole way of life will be disrupted as a result of that. So is that true or not? There are obviously a lot of debates, as we already just heard, right? There are, disagreements on what is the AI definition itself, how we do AI, and also how we extrapolate into the future. Some people are very optimistic about AI. They were talking about AI really, leveling up, over the course of development very quickly, in fact, to the point that they may be able to, generate a new civilization, enable organizations, or be, a propeller or catalyst of new organizations down the road through these multiple levels of advancement. Other people, including my colleague sitting in right here, were less optimistic.
刚开始的话，我会建议你空运少量的测试，等到你销量起来以后，你再做大量的下单，并且每年的4月和10月，你都可以到香港展或是广交会去找你喜欢的工厂，这是我们比美国人优势的地方。第三，设计产品的照片跟写产品的文案，在前期会花比较多的时间，但是这很重要，而且你不能马虎。利用我们的数据资料去配合 ChatGPT 这些 AI 工具，可以帮你省下时间和精力，并且如果你不会英文，也不需要担心，同时你还可以兼顾你产品的图文品质，去提高转换率。当然 ，Amazon 还有更多的技巧和秘密，由于时间的关系，我无法一一跟你分享。但是你很幸运，接下来我要举办一场免费的90分钟的线上 Amazon 直播分享会，在这个直播中，我会无私的分享更多细节，教你怎么一个人从零开始去打造北美的知名品牌。现在你只要点击下方的网址，就能报名下周的免费 Amazon 直播研讨会。如果你对经营 Amazon 有许多的问题，也欢迎随时留言给我，我会在直播时一一帮你解答。那我们就到时见喽，拜拜。
because it is very, very true that there are a lot of limitations in what we see in the current AI systems, not alone some of the fundamental flaws in the design and in the implementation. And others maybe are taking the middle ground. So I want to make this presentation a little bit outside of this debate because we can go on and on without a finishing line. I want to pull back to think about why we care about all these discussions. As Mike just mentioned, somehow AI was positioned half a century ago by a very, very famous hypothesis or test called Turing test, which basically unfortunately sets AI against human. And that's how we define AI. Even though there isn't a clear mathematically rigorous or even quantifiable definition. It's like put two people, or system and AI system and people behind the screen and do whatever you want to do in lingual communication. And the moment you cannot tell them apart, you achieve AI. I would say that this is really a trap because when we scientists and engineers build systems, very rarely we meant it for beating a particular species, or achieving a certain state of the reality. We want to solve problems. For example, if you build a car, you build an aircraft, it will be very lame for you to claim that my goal is to beat a human in running or beat a bird in flying, right? You actually want something more functional and more measurable. And that basically already, hopefully encourage or motivates people to think beyond this Turing test. And in that sense, the target seems to be pointing to what capacity and what utility you want to build out of the system. And also, hopefully in that vein, you can rethink whether the system really is heading toward having morality, having agency, and having free will, so that we can be so scared to stop developing that. On the other side, more than the Turing trap, there's another trap I found it's also more serious and interesting, which I call the Kant trap. It is related to how we build systems and how we implement systems. Over the past 300 years of civilization, we become almost religious and dogmatic about Kantianism, which basically highlights the importance of reasoning above everything, right? So we like first principle, we like clarity and causality, and we reach a tremendous height in physics and many other sciences where we can just sit in home and calculate a few equations and we will predict the position of celestial body and so forth, which leads to such a pride in human civilization and the human being. For example, there is a famous conversation happened right here in France between Napoleon and Laplace. Napoleon asked, hey, do you really need the mentioning of a god in your system? And Laplace proudly answered that we don't need that assumption. So basically, there is a belief that with first principle and with science, we can solve everything in universe, if now, but then sometime in the future. Then comes to some other little, what we call the little cloud in the air, which occludes some of this global glorious vision. For example, is causal reasoning really true everywhere? There are a few cases, in fact, they were challenged. You all heard about the general theory of relativity. One of the bigger consequences of that is that you may be able to do time travel. And when you do time travel, the causality kind of argument becomes shaky, right? And also evolution is not about causality. In fact, Mother Nature never evolved species toward a certain goal by designing the best possible mutation, by having the best possible protein design to achieve certain functions like catalyzations. Right. It is through random mutation, and there is a selection force, which is rather indeterministic at the microscopic level. And quantum superposition, which was reflected in the Schrödinger's cat story, same thing. Even the natural world is no longer exists outside of a human mind independently. Depending on what you observe, you may have different physical realities. And there are also incompleteness in mathematical theory about coexistence of consistency and correctness. So all this basically push people maybe to give a opportunity to think beyond using only first principle approach. I think AI is one of these examples, or maybe a good examples. We still don't know exactly how AI system work to the last level of details. all I can say is that there are certain principles being followed, such as using large models and large data, which was missing from this older version of the slides. Self-supervised learning has been pervasively used, and it is building task-agnostic representations. That's very important. AI systems nowadays is not built toward a single task, but a whole collection of different capabilities, and so on and so forth. In the theory side, we actually don't have a clear idea about what is happening. They may learn, a manifold, which relies on geometric theories. They may learn a distribution of the data and the phenomenon, which of course draws in probability theories. They may do compression using information theoretic operations. We don't actually know for sure, right? But without knowing this, can we make progress? What the goal is, the answer is yes. People actually set goals for building systems and were able to make tremendous progress even before we know all the details. And that's very unique in AI, unlike what we see in physics and other science. Talking about the goal. Setting the goal itself is actually a very interesting problem in AI, and which actually helps people hopefully to demystify a little bit what is LLM doing and what it cannot do. We all have goals in our life, and you can translate them into a executable goals for systems. And here you can even write down into tiers in the form or in the level of difficulties. And here is my pyramid of capabilities, starting from read and write, and then do some reasoning, do some planning, and acting in the real world, and so forth, right? You can define tasks to now make all these capabilities measurable. And that's how engineer came down to the problem, rather than from the first principle and from the theory.
The key to real estate is taking a through cycle view. And if you can come out, back to our original comment, with strong relative investment performance out of the cycle, you're going to do well.
Prominent CEOs, leading economists, iconic investors, insights from the experts. The Walker Webcast with Willy Walker. See who's next.
Welcome to another Walker Webcast. It is my great pleasure to have David Hunt, the president and CEO of PGIM, join me today. David, let me do a quick bio intro to you, and then we'll dive into our conversation, which I've been very much looking forward to. David Hunt is president and chief executive officer of PGIM, a leading global asset manager across public and private asset classes. Before joining PGIM, Mr. Hunt was a senior partner in McKinsey & Company and co-leader of its North American asset management practice. Mr. Hunt has served on a variety of nonprofit boards, including Lincoln Center for the Performing Arts, International Rescue Committee, Graham Windham, and Toigo Foundation. He is a life member of the Council on Foreign Relations. He earned a bachelor's degree in engineering from Princeton University and an MBA from Wharton. Many people say that I have nothing but Harvard Business School graduates on the Walker Webcast, and I want to underscore that I've had back-to-back Wharton.
So diversity for you is Wharton. That's terrific.
I had a Wharton grad last week, and I got a Wharton grad this week, so I love it. We're getting some real insight, David. We're getting some real insight. It's a pleasure to have you with me. Let me start here, David. PGIM manages $1.4 trillion, and I remember Alan Greenspan used to say $1 billion here and $1 billion there, and at some point you actually have real money. In your case, it's $1 trillion here and $1 trillion there. You're pretty close to having $2 trillion of AUM at PGIM. Is that the goal? Is the goal to continue to add AUM at PGIM and go from $1.4 trillion to $2 trillion to $3 trillion?
You know, it's not the goal, but I hope it will be the result. And maybe I can explain a little bit there. I think that the most important thing for us as investors is to deliver excess returns to our shareholders and to our investors, whether that's through a commingled vehicle or through separate accounts. And so we have as our focus investment excellence. And that's what I start all of our meetings with. I start all of our town halls with. And that's what I try to keep us really focused on. If we do that, we will, of course, generate trust and deeper relationship with clients, and we will grow our asset base for sure. But I view that as the outcome of success in investing rather than as the initial goal. In fact, it's not at all clear to me that necessarily my getting bigger is in our investors' interests. because as we all know, sometimes there actually can be a real kind of push and pull between size and investment performance. So I focus on investment performance. The other thing I would say is that in our industry, there's never been more of a disparity around what does a dollar of AUM bring. If it comes through a passive strategy, if it comes through an active equity strategy, if it comes through an opportunistic closed-end real estate fund, those couldn't be more different. And so I actually manage the business on net revenues rather than on AUM. And it's a much better way of thinking about what's the real inherent economic growth of the business.
I find that approach to be A, inspirational, B, insightful, and clearly it has been successful. Was it the same way in 2012 when you joined PGIM? And the reason I ask that, David, is you have so much AUM today at $1.4 trillion that I would assume the difference between $1.4 trillion, $1.5 trillion, $1.3 trillion, not that big a difference as it relates to overall financial performance. But when you first joined, was the focus still on investment performance? Because it's sort of like, Field of Dreams. If you build it, they will come. You got to have the faith that if you build it, they will come. You clearly, if that was the strategy back in 12, you had the faith that if you built it, they would come.
I did, and I will say, and I give the credit to the two people that really were the CEOs before me in the 20 years of its history. That was when I got here. The ethos was investment performance, and it has to do also with the alignment that we have with our owner, Prudential, the insurance company. So when Charlie Lowry, the CEO of Prudential, calls me and says, "How's it going?" What he means is, how's my bloody investment performance? Because you got a lot of my money, right? As opposed to, how much money do you manage? And I think that alignment of interest, which creates this laser focus on investment performance, has been there from the inception, which is about 35 years now. And what I think I was able to do was to take that and say, I can take that focus on investment performance to new markets overseas and also expand the range of asset classes. But the one thing I don't want to change is that focus on we're investors first and our clients' interests come first.
You talked, David, about Charlie calling you and asking kind of how things are going. How much of your AUM is Pru money versus third-party money that you manage for other investors?
So the better way I would say to look at it is how much of my revenue comes, because again, I have this difference between revenue and AUM. And right now it's about 18% of the PGIM revenues come from some affiliated Prudential structure, whether that's the general account or the annuities business or others. So we are predominantly a third-party asset manager.
Start a legacy. Start turning dreams into realities. A better world begins with you. Better communities start with us.
In 2016, when fixed income was, very, very low, and I'm assuming everyone at Pru was working extremely hard to try and get the actuarial tables to work as it relates to the returns on fixed income. Now you have that, if you will, balance sheet at Pru kicking off what is relatively very cheap capital. How much of a competitive advantage is that to PGIM today?
I think being part of an insurance group has never been more of an asset than it is today, for all the reasons that you just described in terms of where we are in the interest rate cycle. But also, I think that we've always benefited from the fact that the general account of Prudential is willing to seed strategies and is willing to invest in new things that Prudential is doing, which, as you know, banks can't really do. So there's a real advantage to being an insurance-owned asset manager. In addition, what we found is that there's a whole new set of technologies which are allowing us to take advantage of reinsurance. So the insurance industry overall is constrained in capital. And what you've seen us do, and many others, is actually to use reinsurance to bring third-party capital in, and then we are the asset manager that sits behind that reinsurance contract. And that's what the Apollos and KKRs and others have been doing. And certainly you saw us a year ago, and then most recently, just last month, announced these reinsurance transactions, which is bringing in significant amounts of capital, backing them with liabilities, and that we're actually using to drive our private asset growth. Because the liabilities of an insurance company and life insurance are very nice matches for the duration that you get on private assets.
And you just mentioned a couple large asset management firms, private equity firms. As you think about the competitive landscape and sort of, if you will, the melding of the private markets with the public markets, and PGIM clearly sits very significantly in both. As you look at the competitive landscape, David, who's out there? I guess the easiest way for me to ask this is BlackRock a bigger competitor to PGIM than Blackstone versus a Nuveen? How do you look at the competitive landscape that PGIM goes into every day? And is it the private capital either?
And that leads you to start building solutions in the form of what we call models. And that's where you see actually where LLM stands. LLM is actually at the bottom of my task list. They do very well in writing and reading and maybe also speaking. But the question is that can they go even above? Or can we assume that they naturally already achieve everything above? Okay? And that basically is a question valid for measuring and calibrating every model we are building. So that leads to what is language model. What language model, to a technician, to an engineer, it is a system doing just one thing, which is the next word prediction, okay? And through that operation of next word prediction, you get all the user experiences, fascinating experiences, answering your question, solving math puzzles, and so forth. But it is not directly automatically translates to understanding, the content, and also, maybe interact with the real world. In fact, it may just be very, very intricate string matching based on a vast memory of remembering all the word knowledges. Likewise, you can make the same assessment about a large visual model. People obviously wonder, do they really understand the word? Do they really reason, or it's just a word or pixel manipulation? But you can think the question from a different angle. Do this matter? Why do you even build this system for? Do you build a system in order to understand the content, or do you build a system to solve problems? Right? And that's why we got this quote from the famous statistician George Box. He said, all models are wrong, but some are useful. If you think from a utilitarian point of view, maybe there is a more pragmatic but actionable approach toward AI systems. For example, we may ask what LLM is not able to do these days. Well, if you ask the LLM to teach you how to swim, to actually navigate you the traffic, they may have an issue because many of the skills that we human beings have, are not best expressed in the form of a language. Just like pouring water, you don't write it, but you watch a video, you know how to do it, right? And there are also a lot of contents that stay outside of the textual literature, and that already sets the limitation about what you can achieve in large language models. And I believe, people knew it, but people just don't, directly connect to the fact that large language model is not there to give you a, understanding the way we human defined it. Right? In fact, the space where large language models, are doing their work is
Longest thing we ever do is live our lives. But life doesn't come with an owner's manual. Might have been nice, huh? But that means we get to write our own stories. Freedom is yes, or no, or maybe. Freedom is for everybody, but it isn't free. It's earned. There are real heroes in the world, but not the ones in the movies. Real heroes are humble. They're not driven by pride. Pride is a terrible driver. Freedom is the roar of one man's engine and the silence of another's. Freedom is the ability to inspire. The most sacred thing in life isn't the path. It's the freedom to choose it. You don't have to be friends with someone to wave at them. We won't always agree on which way to go, but our differences can be our strength.
Very small one in our universe of possibilities and reasoning. And here you can see what's remaining, right? For example, we have the space of real-time and space, and the multi-agency with other people, and the law of natures. All these, don't be surprised that they may not be handled by large language models. But we don't call large language model stupid because they cannot do it, because they were not even made to do that. Right? So in that sense, I want to continue with two examples about what I see to be the future of this AI movement in terms of exploring more space of possibilities. The first one is a agent and a word model, which can help us simulate a cognitive and behavioral activities in the real world. What is a word model? Well, the word model, there are many definitions. One famously defined from Professor Yang LeCun in his seminal articles. And here is my definition. It's a simulator of both the physical world, the emotional world, embodied experience, social experience, and all that. That's basically making up the world you are living in. And imagine that you have a model that can produce contents in all these. Then you literally have a word at your fingertip in the digital form. And how to make that is a technical design, which I'm going to browse away, but they involves, of course, ability to process sensory data, long memory, and ability to persistent memory, and also carry out objective-driven architectures and so forth. Right? But the biggest value of having a word model is to allow you really do reasoning among a bigger space of possibilities. There are, a different way of defining reasoning. We thought that our reasoning is about finding the shortest path toward our goal, or finding the optimal solution to a task. But every one of us probably, from time to time, do something called a thought experiment, which means hypothetical thinking. You just simulate outcomes of potential solutions, and you pick the best one. Right? And that's actually, a very intuitive way of thinking about reasoning, which is less, elegant and mathematically rigorous, but it works. And here is what a word model can enable you. It defines you, a oracle which simulates the next state of the word given the previous state and the action. And this little equation, if you just expand the scope of the possibility and the content, can help you do a lot of things. For example, you can set up your goal, and then you can just do forward simulation by drawing samples, from this distribution or this generative model. And then you have multiple pathways toward the goal. One of them probably is hitting your goal. Others are getting closer or further. And then you can choose the one that is best for your fit or in your budget. In fact, the AlphaGo is an implementation of this idea. It is simulating multiple moves from a particular board position, and then using a Monte Carlo tree search to find the optimal one, and then execute it. Right? You can imagine that now my situation is not the board position, but real-world problems like a traffic in autonomous driving, like a battleground configurations, or maybe something you never experienced before, like how to colonize on Mars and so forth. And you can use the same idea of simulative reasoning to solve many problems. And that's actually what the word model is about. I'm not sure this video is playing, or it is playing. Well, this basically is a video showing you how we might be able to qualify even the quality of the word model by measuring or testing its steerability. Because the word understanding is not very well defined. It is a very subjective opinion or maybe capability for human, but how a word model understands the word. Well, what if you can tell the word model to do things you like, steering the car and moving the objects and real-time instructing a particular behavior, and then the word model execute, that probably gives you a hint about how word model can understand the real world. Right? You can also put the agent into the word model because many word models these days are being equivalent to generating videos or generating 3D contents. But that's not really all the possibilities in the world. The real world contains people. Therefore, agency and our agents can be another content inside the world, and then they collectively generate signals into your artificial brain. And then over there, you can have a thought space, doing hierarchical embedding and putting back the responses, making recommendations of actions and so forth.
A lot can change in 5 years, but the price of your internet plan won't. With Verizon, get a 5-year price guarantee and plans start at $35 a month. Only on Verizon.
So this is a direction we see to be highly promising and important for the AI to go beyond large language models. And here is a sketchy of a potential architecture design down the road where the word model, which is a bigger version of the large language model built on multimodal data, can be itself a module inside an agent model, along with other representations like the goal, the belief, and also the plans, and also interface with the external tools and other things. You can even build a community, as Mike mentioned, or a collective group of agents, which gives you this more collective behavior in an abstracted way. Then you have super agents which can make macroeconomical or societal decisions based on the situations. Right. So again, I couldn't play this movie, I guess. And what is happening here is that I want you to imagine what an agentic and a physical world look like. Oh, it is playing, right? It is actually not what you see in Sora and in Gemini 2, a Genie 2, where you see cool, visual effects and the cool, movies and the 3D renditions of the reality. Agentic world is a world that you experience in real life, where this particular guy, you can see that he is running, he actually is interacting, with the object, inside the world. Imagine that when you drive, if you treat the coming car as an object versus you treat the car as an agent, which has its own plan, its own intention, I bet your behavior will be very different. You may run away from it, you may stop, you may just, go head on. Who knows? But if it's an object, you don't actually feel that complicated to avoid traffic, right? So that's basically what I see to be a promising direction, an important one down the road for the AI system to go beyond LLMs. I want to have a word about whether we should be afraid of this or not. There are a lot of discussions and speculations about the AI system become so powerful that it come after people and kill people. Well, this is more than just a sci-fi. In fact, I didn't see people seriously establish hypotheses and proof or evidences of substantiating that statement. And here, I want to add my thoughts. I think when we talk about agency, free will, moral, and drive, it is a different space than having a task and solving it. it is not very clear yet, our current architecture even have room to accommodate this kind of capability, and also what kind of data, what kind of task, can be used to attain that kind of capability. So I think maybe it's not impossible, but we're not so close to reaching that state yet. To close this part, let me try to expand the space of reasoning even further a little bit, which is in the physical world. And that's where, again, AI can provide huge value than we already experience now. For example, talking about the problem in biology. Well, biology is a fascinating field, but a very, very classical one. Medicine, human health, in fact, is a biological problem, because when you see, say, an organ failure, it's more than just going to the department of liver or brain and get your MRI scan and then take some medicine. You may want to even look into the cellular level lesions of your tissue, your DNA mutations, and your hereditary histories and so forth. All this information provides you a holistic picture about what disease is about. So it is biology. But understanding biology is very complicated. It is a multi-skill subject, go all the way from nanometer microscopic events to macroscopic events in the order of this size, right? And in the past, without the right tool, we take a sliced approach, using data collecting at certain resolution and using models only focusing on one, say, well-defined problems. And these are the tools we use, right? And it is not working very well. That's, in fact, we still, don't understand very well about biology, and designing a drug and treating a disease still is difficult. But nowadays, we have better models, or maybe more powerful models. What's the implication? For example, we see one implication already, right? You can now solve this puzzle of protein structure like we never did before in a very, very efficient and accurate fashion and very fast. And it's important to remember that AlphaFold 2 does not understand the law of physics. Okay, it is a purely data-driven approach that gives you a input-output mapping between the sequence and the structure by training on many, collection of large data. And it's a very different approach, an empirical one, an empiricist one, against the first principle one in solving a big piece of puzzle in science. And it is recognized by a Nobel Prize. And these two contrasts is very, very important to recognize, because first principle approach, however elegant it sounds, it gives you uncertainty of quantification of uncertainty, clarity, explainability, but it is not scalable to many of the problems we want to solve even now. Whereas the AI foundation models gives you that capability in terms of the outcome, even though it is not quite satisfying all the scientific curiosity and also the clarity and the causality. But I think there is a middle ground that we can live up with both and let the two approach to naturally merge rather than waiting, with each other.
Threat hunting is proactive. It goes on the offense. It doesn't wait for alerts or red flags. Instead, threat hunting seeks out cyber threats.
Most defense in the cyber world focuses on the after impact. Threat hunting flips that on its head. Threat hunting takes an idea and says, where do I believe that someone will try to attack my environment? And they try to find that as it happens in progress.
Threat hunting is a much more nebulous, much more vague sort of beginning. It begins with a hypothesis about something that might be in the environment, some kind of activity, some sort of potential vulnerability, whatever it might be, but you don't have the evidence when you start a threat hunt. That's what the hunt is all about.
So in that vein, there has been a lot of amazing developments in the past several months, in fact, using foundation models in biology. And this is one effort I want to highlight, which is called an AI-driven digital organism, which is not about just building one model for one type of data, but building a cluster or system of models that covers different aspects of biological data, from DNA to RNA to protein to cell to tissue and to phenotype. Why this is possible? Well, because we see similar things are happening already, in our cognitive space, with language model merged with a visual model, now with audio models and so forth. So multimodality is no longer a hurdle. The fun part is, of course, is to find the right representation architecture for unique biological data that is different from the human language and the visual. But this is an ongoing research which I believe to be very, very rewarding and interesting. And our approach is to take a divide-and-conquer approach to build smaller models from ground up, and then try to really connect them together through, for example, hierarchical embedding, through cascading of information, and the conditional generation and so forth. They have all sorts of techniques being developed and to be developed to make use of the models in a collective way. And then you can harmonize them, hopefully, to achieve higher predictive goals, which can simultaneously, for example, predict interesting queries from all different levels, all the way from drug design to simulation of cellular environment and the treatment effects. I think this vision is going to be disrupting the science of biology in a tremendous way. Right now, the field of biology are still primarily relying on wet lab, physical experiments and trial to make the discovery, to confirm the discovery, which is a very expensive thing. And with imagine a digital organism which can simulate all possibilities of biological world, what you will probably do is to use the simulator, the AI system, to first do the exploration, right? To weed off the low probable hypothesis, and only output the most probable ones, so that you can do only a few wet lab experiments, to validate. And this is getting the biological science closer to what we do in other places, where such as power plant design, chip design, relying heavily, on simulation and computing instead of trying, a physical production, to explore all possibilities. So I think, there is a potential for such an AI-driven digital organism to be a new paradigm for in silico biological research, just like what we do in other disciplines and science. So here are just two examples I want to share with the audience about how AI may evolve and develop in the next couple of years. And I want to close by making the following remark. Scientists, are supposed to be open and also undogmatic. But it turns out that in the past several decades, we scientists ourselves become rather dogmatic about the approach we take. We become less skeptical about the science itself, right? And this is actually, probably a side product unexpected from Kantianism, because reasoning and the first principle makes you feel so powerful and so satisfying, whereas humanists, who rely on empirical evidences, and having skepticisms, for almost everything, makes people less confident, makes people feel unsafe. But I think with the advancement of AI, which builds on large model, the progress and the outcomes, the engineering products are maybe for the first time in history dramatically outpace our ability to understand every fact and every theory behind the finding. So should we stop and wait for the theory to catch up, or should we carry forward the experimentation, to advance the science, and at the same time, doing the understanding simultaneously? This is a good question we should all face as scientists. So I want to conclude by one example, which again come out of France. Dr. Pasteur, who invented the vaccine, can you call them a Kantianist or a humanist? I don't know, but one thing I know is that by the time he invented the vaccine, we don't have knowledge about DNA. We don't have knowledge about protein. We have very little knowledge about the cell, right? Therefore, that discovery of a vaccine, getting people immune to infectious diseases is a pure empirical finding, and it was adopted and accepted through very rigorous tests. And that ended up saving millions of lives. I think
we like our kids a lot.
We changed your life.
Yeah, you did. Yeah, you did.
For the better. For the better. I tell myself every morning, for the better. Universal Stories, take one.
How do you feel about going to Universal Orlando?
We're going to Orlando. No, stop. We're gonna go to Universal. It's the first time in Orlando.
It's tomorrow.
It's tomorrow.
We're going to Universal
tomorrow.
As a mother, when you want your kids to grow, you never actually want to be reminded. Like, I don't like hearing the C word in our home.
What's the C word?
College. Because we want them to stay our babies forever.
Running. Rosie's in the mindset where she wants to keep the kids small and cute forever. I'm actually excited to see these guys grow up, to see what they become. And I think having great experiences together is the best way to keep that going.
Yeah, I'm gonna be having flashbacks to when we weren't parents just yet. I feel like a kid. 3 days, 3 theme parks, and I'm thinking 3 gallons of coffee. This is a big one. I just knew we were about to embark on a crazy adventure. Oh gosh, you're gonna have so much fun.
I thought she was gonna say, you're gonna have so much to carry.
Oh, the Universal Global's over there. You see it? You're too fast.
Is the ride this way or that way?
Bubba has been doing dad jokes even before he became a dad.
Back then, they were just bad jokes. We are not whirling. Whoa, it's
He has found his ride.
You gotta push up the muscles. Push up the muscles. Sorry, my inner Dom is coming out. Are my muscles glistening yet?
We were on our seats, off our seats. We want some fast action. We want some excitement. On family, that's the phase that we're in right now.
I was loving it mainly because I could see core memories being formed as we were having adventure after adventure.
This is just like our life right now. Look, you'll make it work right here.
It's messy, it's ugly, but darn it, it's ours.
Time to get on up.
Good.
There ain't nothing you can do.
This is the story of my life.
There's something you can do about today.
Romantic as you can be with your kids close by.
We're just walking, no running.
These guys are pretty much like every other sibling set. They don't always get along.
Just do it, come on.
Austin, honey, this is real life. This is what I go through every single time. Oh my gosh, I'm so like what you're seeing now, it's a miracle.
How would you describe your brother?
We call him like King of Annoying. He likes to show off. He's okay, but most of the time, he's dreadful. Please! Let's see, I think that's it. Oh, no, horrendous. Is this some kind of maze?
Where are our kids? Where are they? Kids, I'm coming.
We made it.
I'm so proud of myself. Thank you. I felt like I kind of got the old Baba again. The pre-kids Baba, my husband. Beautiful. Oh. They don't get to see us be us. It was just us being kids again, just goofy. We didn't have you guys yet, so we were actually having a lot of fun.
When you're in the day-to-day grind, it seems like we're all playing multiple roles at the same time. The one role we tend to forget is husband and wife.
And it's those little moments that we're able to seal throughout the theme park. That kind of thing where you don't have the weight of parenthood on your shoulder. It's like writing a new chapter in my relationship with my husband. Like we're reliving our young, puppy love days, I feel like. But on a grander scale. During this trip, it was interesting. I definitely saw a transition. I was able to see special sibling bonding moments come about. We have Austin here, who swore he would never go on the Velocicoaster.
I can feel his heart beating through his shirt.
For a split second, we looked down, and I regretted all of my life decisions.
This environment encouraged this. We had a lot of great memories, a lot of great adventures, a lot of growth.
At home, this would have never happened.
Yeah,
no one bonds over doing chores. This is probably the first time I've seen them depend on each other. And this trip is the start of that. This is the first time I've seen that.
I'm just overwhelmed with just joy.
A memory of an experience should be more than just what you see and hear. It should be what you feel.
This moment is pretty magical. You can do it! No, I love our family. I love everyone's quirks. Being a mom makes you like a superhero. You never know when it's going to be the last time they want to cuddle with you, to play chess with you. Where'd you get that?
I came prepared.
Who are you? We're not the perfect family. We never pretended to be the perfect family. I never pretend to be the perfect mom. But this is such a perfect moment. There's so many levels, I think, of how we enjoyed this trip. As parents, as a couple, siblings. And it's only been 3 days. 3 days, 3 parks, but we have grown beyond.
This is for the architects of tomorrow. The ones who create to make a lasting impact. Who are rewriting the world with tools that push what's possible. For those who build with responsible AI that's secure from the start. So you can build your way and go further, faster. Because whatever you dream of creating, the world is yours to build. Microsoft, yours to build.
We are at the same moment right now in AI where great inventions and great capabilities are being presented. It is us to decide how to mitigate the risk, but also how to balance the speed of innovation in that direction versus being cautious and being risk avert to impose strict regulations about what we are doing. So with that, I want to go back to my first page where outline the future of AI in the next few years. I think the major mission that we want to push forward, including within my own university, is to deploy AI in the larger space of possibilities for reasoning and then find solutions to make that happen and also implement solutions to drive capacities and needs in human society. With that, I want to conclude my talk, and thank you very much for the attention.
Eric, thank you very much indeed for that. Again, another insightful talk for us. A really good note to leave us on what next in terms of responsible AI. Just want to let you know that Eric will participate in our roundtables that will take place just after this section of the program. Again, your opportunity to make this an interactive event. If there are questions that have spiked your interest during that plenary, please feel free to scan the QR codes that are at the entrance to the amphitheatre, and you'll have a chance perhaps to hear your question asked live on stage shortly. All right, next for our second plenary, we're going to hear from Joëlle Barrel. She's a Senior Director of Research and Engineering at Google DeepMind. Joëlle's research interest includes theoretical and empirical aspects of frontier models, as well as early-stage research in artificial intelligence, and as well as the early life sciences. She oversees a team of researchers Europe-wide and as well in North America. She was previously the software lead at Verily, and in 2019, some of you may know that she was the proud recipient of the very prestigious Pierre IV Prize. Joëlle, over to you.
Good morning, everyone. It's a real honor to be here today to share how we're accelerating scientific discovery with AI. My name is Joëlle Barrel. I'm a Senior Director of Research at Google DeepMind. I've spent a bit over a decade at Google, including at Google X, our moonshot factory, and at Verily, our sister company dedicated to the life sciences. I'm now with Google DeepMind, our world-leading in-house AI lab. If there's just one thing you remember from this talk, it should be that we're perhaps entering a new golden era of discovery that leverages AI as a general-purpose tool. At Google DeepMind, our mission is to build AI responsibly to benefit humanity. If we want to frame the moment we are in, it's helpful to reflect on history. The Industrial Revolution captured physical power, moving us from farming to manufacturing. It was about building. The Information Revolution changed how we live, how we work, how we connect with each other. It was about sharing. And now with AI, or ML, it is about understanding.
This is the primary equation. Primer plus foundation equals glue.
Primer plus foundation equals glue.
What are you all doing over there? Are you all stuck?
We believe that AI will power a fundamental social and economic transformation in the world, and it will do so through the sciences. So you're probably wondering, what does a scientific revolution from AI look like? And I'd like to start with a very concrete example in molecular biology that Eric already alluded to, AlphaFold. Proteins are frequently called the building blocks of life because almost all biological processes in every living thing depend on proteins, from the twitching of your muscle fibers to the firing of your neurons. In 1949, Frédéric Sanger correctly determined the amino acid sequence of insulin, one particular protein. Think of that amino acid sequence as a string of beads, where each bead is one among 20 letters. Frederick got the Nobel Prize in 1958 for that discovery. And that discovery also started molecular biology as a field. Scientists in molecular biology were then keen to determine the shape of a protein, its 3D structure. Knowing that structure matters if you want to understand, control, or modify a protein's function. For example, if you want to predict what molecules bind to that protein and understand various biological interactions, if you want to discover new drugs. Finding a computational solution to that problem is far from trivial. It's known as Levinthal's paradox. There are about 10 to the power 300 conformations that a typical protein can take. Enumerating all possibilities would take longer than the age of the universe. And yet somehow in nature, proteins fold spontaneously within milliseconds. Protein three-dimensional structures are obtained using two popular experimental techniques, either X-ray crystallography or nuclear magnetic resonance NMR spectroscopy. You can use one or the other depending on the size of the protein, whether it can be crystallized, or whether you want to study it in its native solution environment. And that's actually quite difficult. X-ray crystallography requires a synchrotron, which is really big. Once you have an image, you mathematically solve the inverse problem to get to the protein structure. And after decades of experimental work, about 170,000 structures had been determined and collected in the Protein Data Bank, PDB, which is an incredible resource, and I'll get back to that. In 1994, the CASP competition started, Critical Assessment of Techniques for Protein Structure Prediction. Predictions have to be accurate to the width of an atom, that's less than 1 angstrom, to be of use to experimentalists. This competition provides a blind assessment. It leverages protein known experimentally, but not published yet. And for its 13th edition in 2018, AlphaFold, our AI-based solution, placed first. It was the very first time that machine learning was introduced and a main component of the prediction. AlphaFold 2 won the 14th edition of that competition in 2020 and achieved atomic accuracy, which led the organizers to declare the problem solved. The scientific community immediately recognized the importance of this discovery. Nature called protein structure prediction the method of the year in 2021. And Demis Hassabis, DeepMind's co-founder, John Jumper, one of my scientific colleagues, were awarded the Nobel Prize in 2024 in chemistry for AlphaFold. So how does AlphaFold work? The Protein Data Bank, which I mentioned earlier, was used as the starting point to train AlphaFold. You feed raw data to the model. Here, the particular sequence, SIFSY, I'm not going to read it all, represents a protein known as T1049, also identified as 6Y4F. Ultimately, AlphaFold predicts the structure of this protein, which is an adenosine tip protein, crucial for bacterial attachment. The central diagram outlines what AlphaFold does, and Eric also had a beautiful one in his presentation. Evolutionary and physical constraints were built into the architecture, along with the learning. And in the full end-to-end system, there's a recycling stage that iteratively refines the structure prediction. On the right, you see the final product, a visual representation of the predicted 3D structure. This ribbon diagram shows the protein's backbone folding into its functional shape. The 93.5 GDT indicates the high confidence in the accuracy of this prediction. GDT stands for Global Distance Test. It's a measure of similarity between the predicted and the experimentally determined protein structure. AI models like AlphaFold can predict protein structures, but how do we know that those predictions are accurate? And this is something we heard earlier this morning as well. How can we be confident in the prediction of those models? This slide highlights the crucial ability here of the models to assess their own confidence, giving us a measure of reliability for different parts of a predicted protein. On the left, you see a protein structure with segments that are color-coded by confidence level. Dark blue means very high confidence. The model is quite certain about the structure in those regions. Lighter shades of blue, yellow, orange show decreasing confidence. Notice that some parts are consistently dark blue, likely representing well-defined structures like helices. Other segments, for example loops, show lower confidence, suggesting that these regions are more flexible and harder to predict. And on the right, you see a contact map, which provides further insight. It shows predicted interactions between amino acids. Stronger interactions mean closer proximity. The blue square highlights a confident domain, a region with lots of strong interactions, matching the high confidence of the structure. And the red rectangle shows a potentially disordered region. The interactions are weaker, less frequent, reflecting the flexibility and uncertainty of the structure. There's more wiggle room, if you wish. So the key here is that the models aren't just giving structures, they're giving us a sense of how reliable the structures are. High confidence regions are more trustworthy, and low confidence ones might need further investigation. This information is crucial for researchers that allow them to focus their efforts and interpret the results more effectively. AlphaFold has now allowed us to map over 200 million proteins. That's pretty much every protein known to science. So we then consulted with experts in biosecurity and ethics to assess the risks and develop guidelines for AlphaFold's use. It was released in phases, starting with a limited release to researchers and gradually expanding access while monitoring for potential misuse. We open sourced the AlphaFold code and created a database of protein structure predictions that are enabling researchers worldwide to use and build upon the technology. And you can actually very easily use it. If you search for AlphaFold server, you can type your own favorite amino acid sequence and get a beautiful protein. So I encourage you all to just try it. It's now been leveraged by more than 2 million scientists worldwide, and it's become a standard tool in the biology toolkit. I'd like to share a couple of examples. We all know that plastic pollution is a threat to the environment. AlphaFold has helped researchers to make breakthroughs that could help solve this problem. A particular team in the UK was able to screen 100 candidate enzymes in 2 days, supporting their work to potentially engineer faster, more stable, cheaper plastic recycling enzymes. In the race against drug-resistant bacteria, bacteria have evolved the ability to defeat modern antibiotics, and that's quickly becoming a global problem. With new antibiotics thin on the ground, scientists are looking for a different approach. Can we actually target the resistance mechanism of bacteria? Blocking the mechanisms, which is controlled by enzymes, should allow existing antibiotics to continue to function. But understanding the structure of these enzymes have proven incredibly challenging with purely experimental methods. So AlphaFold has helped researchers reveal structures within the resistance mechanism. This is accelerating their work on possible solutions to that problem of antimicrobial resistance. One last example. As you might know, malaria is second only to TB, tuberculosis, in terms of its devastating global impact. It killed roughly 600,000 people in 2020, mostly children under the age of 5. And existing vaccines only target the first stage of the parasite's life, and that has limited efficacy. So a vaccine effective at every stage of the life cycle would help prevent the transmission of the disease, as well as protecting those exposed. AlphaFold has helped researchers understand the full-length structure of a critical protein related to the disease. And that breakthrough marked a turning point in their work, enabling further research into a transmission-blocking vaccine to help combat malaria. What's important in all of those examples is that AlphaFold is a tool in the toolbox. It's not enough, but it's critically accelerating a lot of the work. Now, AlphaFold 3 has moved beyond proteins and can predict the structure and the interactions of almost all of life's molecules. You can think of AlphaFold 2 as solving the static picture of a protein. And AlphaFold 3 is taking the first steps towards modeling the interactions and the dynamics. It can model interactions between proteins, but also between proteins and other biomolecules. So now that I've taken you through a journey through the wonders of biology, I'd like to take a step back. Because you might wonder, why was a company like Google DeepMind interested in protein folding in the first place? And what does it tell us about AI-assisted scientific discovery more broadly? You might remember that Google DeepMind started by solving games. We started with Atari, training AI only on the raw pixel input, with the goal of maximizing the score, just that dedicated goal. And it learned how to win on its own. And it wasn't just Atari, it was every game. Our most notable game's breakthrough was mastering the ancient and complex game of Go, arguably the pinnacle of games. Go is incredibly complex for a computer to solve because it's very complex. And AlphaGo learned to play Go by playing against itself millions of times. To test its skills, we played against the 18-time world champion Go player Lee Sedol. More than 200 million people watched the game, and AlphaGo won 4-1. It didn't just win, but it also came up with creative strategies never seen before. For example, the famous move 37, in which it put a stone on the 5th line, very unheard of, and all the experts thought it was a mistake, but it wasn't. So AlphaGo happened at a critical point to really demonstrate that the learning systems are able to learn something useful. AlphaGo and AlphaFold have 3 ingredients in common. They're the key ingredients we like to see before we tackle a challenge with AI. A massive combinatorial search space where neural networks can very effectively guide the search. A clear objective function or metric to optimize or to hill climb against. And third, either lots of data or an accurate and efficient simulator. And in parallel, we see that advancing the frontier in science requires dealing with tremendous scale and tremendous complexity. So it's not surprising that over the years, we've seen also a tremendous increase in AI adoption across the sciences, spanning all the sciences: agriculture, biology, chemistry, geology, mathematics, physics, etc. And I'd like now to take the remaining of my talk to show you a handful of examples across those domains. Besides leveraging AlphaFold for drug discovery, we're also using AI and generative AI to make more accurate diagnosis, for example, in radiology, to remove administrative burden, for example, by automatically taking notes or writing summaries, and to help comprehend massive amounts of data to enable precision medicine, for example, in the work we're doing here in France with the Curie Institute. MedGemini is our family of models fine-tuned for the medical domain. We've explored the broad capabilities of Gemini, our most powerful large language model. We've inherited its native reasoning capabilities and the long context ability. And we've also explored capabilities in specific domains like radiology, pathology, dermatology, ophthalmology, genomics. Here you see an example of a dialogue with MedGemini in the radiology setting. In this interaction, it demonstrates its ability to analyze a chest X-ray and conduct a dialogue with a primary care physician. It identifies mild degenerative changes along the spine and can answer questions about the reasoning which led to this finding, demonstrating general medical knowledge about degenerative disc disease and distinguishing between correlation and causation in relation to the patient history of back pain. And it's capable of explaining its findings in layperson's terms, which is really helpful to facilitate patient understanding and communication in clinical settings. In materials discovery, we built a tool called GNOME, which is short for Graph Networks for Materials Exploration, which uses deep learning to determine the structure of more than 2 million inorganic crystals. Of those, the tool was then able to identify which ones were stable at low temperatures, which is opening the door to new materials that could power future technologies, ranging from superconductors, powering supercomputers, and next-gen batteries to boost the efficiency, for example, of electric vehicles. GNOME uses 2 pipelines to discover low-energy stable materials. A structural pipeline, which creates candidates with similar structures to known crystals, and a compositional pipeline, which follows a more randomized approach based on chemical formulas. And the outputs then are evaluated using established density functional theory. Those are then added to the database, which informs the next round of active learning. And in a way that's quite similar to what happened with CASP in the AlphaFold example, once we finished that discovery effort, we then searched the scientific literature, and we found 736 of our computational discoveries that were independently realized by external teams around the globe. So you see those examples on the right. A first-of-its-kind alkaline earth diamond-like optical material, for example, and a potential superconductor. We've released that database of newly discovered crystals to the research community. It is giving scientists a catalog of promising recipes for new candidates, and we hope it will help them test and potentially make the best ones. Historically, weather forecasting is done through numerical weather prediction. It leverages physics to simulate atmospheric behavior. And we use observational data from weather stations and satellites, so the temperature, the wind speed, etc. These models process that data with supercomputers, performing complex and time-consuming calculations. We've trained a few different AI models to improve weather predictions. GraphCast, for example, is trained on historical data from the European Center of Medium-Range Weather Forecasts. And it delivers 10-day weather predictions at unprecedented accuracy in under 1 minute, compared to the hours needed when using a conventional approach. And WeatherNext offers earlier warnings of extreme weather events. This is our latest weather model. If you think of cyclones, also known as hurricanes or typhoons, it's really helpful to get better and more advanced warnings of where they'll strike and when they will strike the land. So WeatherNext delivers superior predictions of the tracks for those storms. Initially, it's an ensemble forecast, so it shows a wide range of possible paths for the typhoon here, Typhoon Agibis, 7 days in advance. And you see that the spread of the predicted path tightens over several days into a high-confidence, accurate cluster.
One wash, it smells so clean. Downy, rinse and refresh, it's a dream.
As they approach the coast of Japan. Nuclear fusion, and Eric also alluded to it. Fusion power is the holy grail of energy. It's clean, essentially unlimited energy. But one of the many enormous technical challenges is to control the plasma inside the reactors. You need to think of it as hotter than the sun, so you really want to avoid for the plasma to touch the walls of the reactor. We've partnered with the Swiss Plasma Center, which has an experimental reactor in Lausanne, to successfully develop and use reinforcement learning to control the plasma inside the reactor by adjusting the voltage through the magnetic coils 10,000 times per second. And we've been able to use this system to reshape the plasma into different shapes, including some that had been completely missed by traditional ways, to see how we can optimize the fusion process. So I could not give a talk here at École Polytechnique and not include a slide or two on math. We're leveraging AI to solve mathematical problems, and we tested them against some of the mathematical Olympiad problems last summer at the IMO 2024. AlphaProof has demonstrated capabilities that are approaching gold medal level at the Olympiads. It's a system that trains itself to prove mathematical statements in the formal language Lean. AlphaGeometry is an AI system that solves complex geometry problems, and were applied here to problem 4, for example, in that competition. Remember Move 37 for AlphaGo? What I find most fascinating is to hear how mathematicians leverage these tools to wander into uncharted territory and build new intuition. Through vision language action models, robots are able to figure out how to do things that they were never explicitly programmed to do, which was impossible just a few years ago. If you were to see the video, you could see, but I hope you can picture how robots can learn complex two-armed tasks from human demonstrations or simulations. And here's another example that leverages Gemini 2.0, our most capable and advanced model. There's a lot of potential to harness this for robotics. So we're experimenting with agents that can help in the physical world by applying Gemini's spatial reasoning capabilities to robotics. They have the potential to make interacting with robotics much easier. So if you played the game Jenga, where you have to remove those blocks of wood, this is a video you can find online, but you would see the robot doing it very carefully, and the tower stays put while they remove that piece of wood. And a human comes in and destroys the tower just to demonstrate that it wasn't glued and it's actually a real Jenga tower. Robotics is both a scientific and an engineering discipline. That's why it's not the focus of a keynote this morning, but it could be. It really deserves a lot of time and consideration. I encourage everyone to pay attention. A lot is going to happen in robotics in the coming years. So in the same way that AlphaFold has revolutionized biology, we believe that we're entering a new golden era of discovery, where many scientific fields will be revolutionized by AI. This is science at digital speed. It is therefore critical that we train the next generation of scientists accordingly, and that we bring diverse perspectives to ensure that AI benefits everyone. I thank you for your attention.
Joël, thank you very much indeed for your plenary today. Really good to get some real-life examples of how AI is, impacting our lives already and will continue to do so, perhaps in more efficient ways in the years to come. That concludes our plenaries for this morning and takes us into our roundtable. The name of this roundtable is going to be Artificial Intelligence at an Inflection Point. Where do foundation models actually lead us? Now, that roundtable is going to be moderated by Sébastien Mayer, who is AI Project Manager at the French Ministry of Ecology. So welcome to you, Sébastien. Alongside Sébastien, there'll also be on stage Edgy Kamar, who is VP and Managing Director at AI Frontiers and at Microsoft Research. We'll be hearing also from David Cox, VP of AI Models for IBM Research. And we can welcome back Eric, Emmanuel Candez, if he's back in the Poincaré Amphitheatre, and Joël Barrel. Just a quick reminder as everybody kind of makes their way up on stage. I said it to you before, those QR codes are going to be particularly important if you do wish to ask a question to any of our expert panelists. Now's the time. It could be a simple question just to get a better understanding of a particular definition of one of the terms that you've heard today, or something more complex. The choice is yours. Let's make today as interactive as possible. Okay, so can the participants of our roundtable please make their way onto stage? So Sébastien Mayer, if you're here.
Unlock a new world of efficiency with Asana. Identify blockers to keep work, projects, and goals on track. Try for free today at asana.com.
Edgy Kamar, David Cox, Eric Jing, Emmanuel Condes and Joël Barrel. We're still waiting. Is Sebastian?
It's not what's next, it's where. Where startups and global players in bioscience, aerospace, tech, and energy coexist in a vast and vibrant ecosystem, and the most competitive tax incentives in the US fast-track success. If you believe your business can go anywhere, this is the place to bring it. Puerto Rico. It's not what's next, it's where.
For soothing relief from sore noses and sneezes, trust Puffs Plus Lotion this cold and flu season. America's #1 lotion tissue.
Fine views of the world. Yeah.
Maybe we can grab the last one. I don't know which one is working, so. Are we missing anyone? Amen. Du coup, on a combien de temps, Sébastien? On garde le temps ou on raccourcit un peu? 40 minutes, d'accord.
Ladies and gentlemen, welcome to the very first roundtable of the event AI, Science and Society, hosted by the Institut Polytechnique de Paris. My name is Sébastien Meyer. I am quite familiar with this lovely place, École Polytechnique, which I graduated from a few years ago. In the name of the XEA group, the AI alumni community of École Polytechnique, I am very pleased to host this high-level roundtable, AI at an inflection point. Where do foundation models lead us? I will now let the speakers present themselves in a few words.
I'm Eja Kamar. I lead AI Frontiers Lab inside Microsoft Research. And I guess we are saying a few words about just framing the conversation. I'm seeing that the frontier models are giving us a new programming paradigm, a computational paradigm to build new applications, and also build the ecosystems of the future that will be really shaping our society and our world. And I'm very excited to be here having this diverse and interdisciplinary discussion that I hope will be able to shape what these ecosystems and platforms take us in terms of using AI for the good.
My name is Emmanuel Candice. I'm a professor of statistics, of mathematics, and of electrical engineering at Stanford. I'm also working for companies in the Silicon Valley. and I'm the director of Stanford Data Science. I'm very excited to be here. I'm mostly interested in the interplays between AI and statistics, quantifying the uncertainty from AI outputs, and how we can inform reliable decision-making, as well as how we can use statistical ideas to improve the quality of the models we train.
Hi, everyone. I'm Joëlle Barral. I'm a senior director of research at Google DeepMind. I also graduated from this prestigious school and then spent time at Stanford and in the Valley. And I now lead teams that are working on foundational research in AI, mostly based in Europe and North America. And I'm really eager to have this discussion. I think we're all trying to envision what the future could look like in which AI is really at the service of society.
My name is David Cox. I'm the Vice President for AI Models at IBM Research. I lead our global effort to build foundation models, LLMs, internally. We have a global team across a number of cities around the world. And I also am the IBM director of the MIT IBM Watson AI Lab, where it's a joint lab between MIT and IBM where we do advanced research together. I'm a recovering academic, just as a confession. I was a professor at Harvard before I joined IBM. This is kind of like my first real job, and my mom's very proud of me that I finally got out of school. I'm really excited about this moment because I've never felt like there was so much change in the air and so much opportunity to actually bring it to real value, but at the same time, many challenges. We have proprietary versus open as a major sort of battle line that's formed. We have amazing technologies that are sometimes hard to use, and they don't give the outcome that we want when customers try and use them. So I think it's a tremendously exciting time. So much we can do, so many opportunities. So I'm very pleased to be here and grateful for the invitation.
My name is Eric Xing. I'm the founding president of the Mohammed bin Zayed University of AI in Abu Dhabi, UAE. I'm also a professor of computer science in Carnegie Mellon University in Pittsburgh, USA. And also I'm a co-founder of a new startup called GemBio, which builds foundation models for biology. You can see I wear multiple hats, and this topic of AI and what we do with foundation model, what's the future, to me is a fascinating but very, very complex one because I'm both the consumer and also the producer, of those models. And I've seen issues, all over the place. But maybe I want to, finish the introduction with one thing. Many people thought that, we've done enough AI, it's so risky and so powerful, we should slow down and understand more. I'm a strong advocate to basically go even faster because I don't think, the more we do AI, the more I feel that we know very little about the foundation, the application, and also the potential. And that only can be discovered by doing more. You double down and triple down, so you discover more questions and risks. And then you talk about management, regulation, and maybe compliance. Thank you.
Organic Valley, protecting where your food comes from. From the makers of the #1 most awarded serum, introducing new Super Cream. Only Olay.
Thank you very much. Let's deep dive into one of our topics. Many current foundation models excel in language processing, but struggle to integrate other modalities like vision, audio, or biological sequences. Also, they struggle to perform well on some specific tasks. According to you, what are the key obstacles to achieving truly multimodal foundational models, and what are advancements in model architectures, training methodologies, or data sets can we have to address this issue? Dr. Barral, as you've presented, Gemini, would you like to start?
Yeah, so I'm happy to start. And as we've seen this morning already, we have large language models that are incredibly capable already, right? Like we can have a dialogue with them, which for many of us who worked on AI for many years, we never thought was going to be at that level of maturity within our lifetime. So they're already very impressive, but you can also trip them very, very easily. And I think for those models to be truly useful, they need to be multimodal, and they need to really be more understandable as well, to your point. So for multimodal, the multimodal aspect, we really saw it with MedGemini. So for those of you who missed the talk, MedGemini is Gemini, our large language model, the most powerful we've built, fine-tuned for the medical domain. And to be able to, you need to do that because the medical domain is really an expertise domain. So you need to make sure that your model understands medicine and understands the specificities to be able to be helpful within that domain. And the first thing is indeed to feed it various data. So in the medical domain, you have your electronic health records, that's text. You have a lot of textbooks, but you also have many images, and they can be quite different from the images you take with your cell phone camera day in, day out. So some of the capabilities of the foundational model, the fact that it knows what to do with those daily images, can be transferred to the medical domain, but it's not enough. When you think about digital pathology, those are humongous slides. So that presents specific challenges in terms of just the infrastructure to be able to train those models. And then you have a wide variety of types of data. So whole slide pathology images, but also radiology images, MRI, X-rays, CTs, etc. You have your genomics information, which is an incredible source of information, but also quite idiosyncratic in terms of the format and the structure of the data. And so you need to really factor that in. You also have data that is very often not in the same abundance as you can have with, again, your dogs and cats and things that everyone takes pictures of every single day. So that requires you to think a bit differently in the ways you're training your models. But you ask about the challenges, and I think the biggest challenge for anything we do, especially in healthcare, is how we evaluate our models. Like, what are the benchmarks? What are the multimodal benchmarks that are going to allow us to be confident that our models are getting better and that they're getting to the level that they can really be helpful? So in the MedGemini work, we pushed a particular benchmark, which is called MedQA, which has been an academic benchmark that various groups have hill climbed against. I mentioned in my talk how it's important to have an objective. So that was our objective, really, to show good performance on that benchmark. But then we also demonstrated that we had saturated it, meaning the remaining couple of % were not really something meaningful that we could continue to improve against, because the nature of the questions were, those questions were ambiguous. They don't necessarily had a definite answer. And in medicine, this is something we've learned over the years. Even in the previous phase of AI with narrow AI, we did a lot of work in diabetic retinopathy. And when we did that work to be able to establish the ground truth, we worked with many ophthalmologists to ask them to label the same data again and again and again. So either themselves doing it a few times with some time in between, or having different experts do it. And then we compared. And it's really hard to establish a ground truth in medicine very often. For that example, we ended up having a beautiful visual representation of the discrepancy between physicians. And they were all board certified, so very, nothing against them, like very capable physicians, but it's just really hard for a human to judge the images. And we even made a t-shirt out of that metrics because it was so telling that it's hard to establish a ground truth. And so I think that difficulty is even more amplified in generative AI, where really establishing those benchmarks is tricky and is also very specific to a particular context. So in the US, for example, the field is quite advanced, so many different groups have started on that journey. But in many countries of the world, people haven't really started to think of the ways they will want to evaluate those models.
In a world where the sky is not the limit. Our brave cadets will go to limitless lengths.
This is your commander speaking.
They'll be evaluated, tested,
I need altitude, not attitude.
and pushed to their limit.
Buckle up.
As they launch lashes sky high
The time has come. Don't mess it up.
and beyond. Sky High Mascot, Maybelline, New York.
Maybe I could just step in and add to those points. I mean, I think one challenge that we sometimes see across domains is that the volume of data that we have available for text isn't available in other domains. It can be harder to get any data. It can be hard, like there are cases where that amount of data doesn't exist in the world. Humans haven't even produced that much for certain kinds of things. So there's an interesting mismatch there that I think sometimes companies, for instance, will struggle with, where they want to do the AI thing, but they actually have relatively small volumes of data. But then at the same time, there's something really interesting about how almost every domain and modality we have can be mapped into language to some extent. And it's sort of wild that we can just sort of project images, time series, whatever we want to project, you just project it into the space of this language model. And I think it's actually saying something kind of profound about our ability to express lots of different things, including kind of out-of-domain modalities with language. But it's going to require development. It's going to require additional applications. I think traditionally, things like computer vision have been, obviously the computer vision community wanted to come along and participate, and we have vision transformers and we have multimodal vision language models. But then there are other domains like time series, which are actually quite like classical in some sense. And super important for business, where there's been relatively less attention. And these are some of the things we're working on. We're actually finding that you can build pretty good time series models, but we're just getting started and then thinking about how that mixes together. So it's an interesting example of pulling together different disciplines, sometimes older disciplines, bringing them back and combining them, and not necessarily accepting the sort of narrative that people sometimes do, that it's just one model will just sort of organically do everything. I think bringing those different disciplines together is actually really important and enriches both sides.
Maybe I can also add to the excellent discussions so far. I want to maybe raise two additional challenges, one technical one and another cultural one. The technical one is that we've seen success of large language models. And with many people, believe that that lays out a very good technical roadmap. You just make model bigger, you replace language data with other data, and then you go the same routine, and hopefully you get something amazing. But the truth is that every science, every data, and every problem are very different. For example, people say DNA is a sequence of characters. Therefore, the language model architecture should work also on DNA, maybe on protein. This is very naive. In fact, the DNA and amino acids and the nucleic acids speak a very, very different language, not along the cell structures and other dimensionality where functions and activities can be found. So there is a lack of, how shall I say this, enthusiasm or daring spirit of exploring new architectures, including new representations, new tokenization, and the new algorithms, new loss functions, in the architecture. I think this space is owned by a small amount of very, very core people with the resource and with maybe the right data, but the community is not big enough. And that's why, as a whole, we see, academia and maybe even, researchers industry by and large as simply practitioners and followers of a given prescription and try to make instances of it. And that leads to my second question, which is the cultural one, how to change that. In academia, I have to say that in the past several years, it's disheartening to see that many of the people in the academia who want to do deep learning and large-scale machine learning and AI had to quit their position and join industry, or they just do something very different, which is not very relevant, to be honest, to what we see as the modern AI. They do maybe some fine-tuning, they may do some prompting, some kind of a follow-up incremental work, rather than being the leaders in this field and creating new architectures and new theories and so forth. There's a challenge, in terms of how we incentivize, how we enable them, empower them, students and faculty and researchers alike, to jump onto harder problems and be ahead of, in fact, the industry, and being the intellectual lighthouse and generating new ideas. So I, as a president of the university, have been thinking very hard how to create that environment. There are a lot of legacy and mindset that is very difficult to disrupt, coming from how we evaluate tenure promotions, how we reward publications, and how we define salary and so forth. And also, of course, people in the university have themselves problems. There is a sense of entitlement. When faculty, students see 4,000 GPUs, it's very different compared to how an engineer in the university, in the company see 4,000 GPUs. I can tell you that in the university, the way they see that, oh, you have 4,000, can I get 10 of them or 4 of them? And therefore, I still launch my small problems onto that. But the industry, let's say, oh, let's group together and work on a model that consumes all these 4,000 GPUs and make it bigger. There's a different mindset between these different communities. But I think down the road, there is an opportunity and there may be even a need to reimagine or redesign, culture and mechanisms, both in industry and the university, so that we can be more productive and more risk-taking, in advancing the research.
As a follow-up to the question of evaluating multimodal foundation models, I would also like to have your point of view, Dr. Candace, as you also presented earlier, confidence-driven inference, your work on this topic. Would you have a...
Yeah, I think more generally, wherever you go work in industry, we're seeing AI systems as being linked in enormous pipelines. And for example, I work in a big financial company, and then there's this issue of compliance. Compliance, what happens is that you have a legal document that needs to be translated into a set of rules that a portfolio manager needs to obey, as to not make, otherwise you become uncompliant and the company becomes extraordinarily liable. So we want to automate these tasks. This is a business of hundreds of millions of dollars. Of course, we think that AI could automate these tasks, but the question is, how do we know that it did it correctly? Because if the AI actually encoded the wrong set of rules or just made one mistake, this can have disastrous consequences. And likewise, I think you all have experience with interacting with ChatGPT. You might ask ChatGPT some medical questions that will actually decide how you treat yourself, whether you go and see a doctor or not. How do you know that what is actually being passed on to you is correct? So that's why, some people are actually questioning the whole enterprise, which is that if we need reliable systems in the end, and they depend on so many components that are so reliable, how do we make sure that the whole thing is reliable? So we're working on this. I think I should say that this issue of what I want to call statistical quality control has what basically fueled the progress in manufacturing in Japan, for example, in the 1950s. But I think what we're working on is to say, okay, is it possible to assess from data? Perhaps I have a human actually score whether AI did something correctly or not. And is it actually possible to score a task that an AI did? And so a high score would be 99%. And that means informally that 99% of the time, I say 99%, the thing is done correctly. And so I'm not saying a human should not look at it. I'm saying that, you know, maybe I can present 2, 3 options to a human. The human will say, yep, that's a correct one, and that saves an enormous amount of time. Think about my compliance example where I would present a menu of options and you click on the right thing. If I say 20%, then that needs a lot of review. And I think it's only by sort of coupling, at least in these high stakes problems where reliability is essential, that we need statistical ideas to be able to quantify how certain we are that an AI automated a task correctly. At Stanford, we released a paper not long ago that basically takes answers that ChatGPT gives you when you prompt ChatGPT and would actually parse the answer into a series of claims. We'll filter out claims that we believe are incorrect. We'll keep a certain of claims, and they'll say, you know, with probably 80%, Emmanuel, I think this biography of Joel is correct. And so what I have to understand with this is that whenever our system says 80%, and I look at all biographies, and I will say that 80% they're indeed correct. If the biography of Joel is 20% correct and you are about to submit it, then you have to be a bit careful about what you're about to submit. So I think it's extremely important to augment AI systems with these notions of statistical control that have improved manufacturing so much, and that I think will improve engineering enormously in years to come.
You talked about statistics complementing the AI systems we are building. What I want to say is that there is also a lot of ideas from systems all the way to human-AI interaction that plays a part in terms of putting these AI systems into the world in reliable ways. So when we look into the systems that are built at Microsoft, for example, yes, at the core of it, we have the foundation models, small models, specialized models, all stack of models that become the base layer of this infrastructure. But these systems are no way just prompting a model and getting an answer and providing that answer in the simplest way to the user. It actually takes a lot of different technology pieces coming together to make sure that these systems, these models are being complemented by a set of techniques to reach the level of complexity, capability, and reliability needed by the real-world applications. For example, when we look into extending the capabilities, detecting hallucinations, fixing those hallucinations, we go to the path of multi-agent orchestration and look into different models complementing each other in its execution with the right workflows, and that becomes a really capable way of putting these systems into the world. But the other part is there are a lot of ideas from verification, from systems point of view, checking the correctness of solutions that really hasn't been incorporated into the LLM execution yet. But what I'm seeing is that many ideas of decades of research from AI, systems, statistics, and human-AI interaction and collaboration will make its way into the stack that we are building right now. So what I see at the end, I don't think it's just going to be the evolution of the models and advances on the models, but it's going to be the whole set of ideas from different disciplines in computer science and beyond coming together to make these systems happen.
Yeah, I want to just wholeheartedly agree with that idea that people kind of focus on the models as being, everything's about the model. And they forget that there's a system that this is built in. And that system is also a software system, and it's also it's a socio-technical system as well. Like there's people, there's processes, there's rules. And I think there needs to be a whole new discipline. You mentioned this earlier, like a new way of thinking about how you build computing systems that incorporates these elements, because they do amazing things, and that perhaps is, they have amazing feats of natural language understanding and generation. That might be their most, interesting property. But the other really interesting property is that they're wrong a lot of the time. Like, we've never built systems like traditional computer systems that can have those kinds of error rates and like hard to detect error rates. So in some ways, maybe the most interesting parts about the computer, both the systems engineering, which you mentioned, and then also the human-computer interaction that you mentioned, like we need to build new ways of thinking about how do we deal with that level of uncertainty, mitigate it and remove it, or how do we surface it for humans so they can make, have some understanding. And that might also involve changing the people too. If we're creating calibrated uncertainty estimates of whether this is right or not, like people have to understand how to operate with that, or you have to bring it to them. So I think there's actually just a whole world of really interesting computer science around the model, like the kinds of cross-disciplinary work that's been going on in computer science for a long time, but in some ways maybe the models have sort of taken some of the air out of the room, which is paradoxically, causing us not to focus on these kind of cross-sectional things that I think are really important and really interesting. So it's been really fascinating to watch people building real applications and enterprises in our work, and looking at, and I think that we're going to have huge gains even beyond the rocket ship model performance, which is going to continue to increase in changing how we work with them and to make them more reliable, more trustworthy, less prone to sort of unintended biases and all that kind of stuff. I think that's going to be, really define how this field evolves over the next few years.
I think when we talk about the evaluation in the AI system foundation models, it's more than a technical problem. It's also a social problem because people are so deeply involved. Probably people heard about the Tesla story, right? So the electric car, the self-driving car, actually are safer, okay, than the human driver if you measure the statistics. But every time, when Tesla commit an accident, it's a big news in the headline. And people forgot about how badly we are as a driver, right? So in a sense, that number, is not just a code number. There are emotions, other things, human factors into that. So that part is, for me, very hard to quantify. Another example is AI's output is solving maybe too hard a problem under a too high expectation. We forgot that, in fact, we are not seeing generative results and the computation results just from AI for the first time. If you look at a picture of the black hole from telescope, or you look at the picture of an electron from an electron microscope, people forgot that they are actually computational results. These are not what you see. Okay, these are literally computed from some signals they picked up. But why people rarely challenge that? Somehow you feel like you see it, and it's easier to believe. But the AI is producing a much more intricate and complex outcome, which is a language, a narrative, and maybe a solution, which makes them feel like you are part of the person to judge it and to actually even push back. It gives you this more intimate dynamics between the outcome and people. I think right now, when we design the validation, we suddenly push back and say, oh, it's like evaluating a microscope. But it's been not fair because we put a lot of other elements into the evaluation. And I think one of the future open topic is how to quantify that part of the variables and uncertainties, in addition to the outcome created by the system.
Many foundation models are increasingly performing well in tasks different from image classification or text generation. We could tell that they start to have emerging agentic behaviors, and we will see this more and more in the future. So building on top of what you just said, how can we design these systems to be robust, reliable, and align with human values and goals? Dr. Kama, as you worked on AutoGen, would you like to start?
My lab has a big focus on agentic AI, but it's also a coincidence that my PhD thesis many years ago was on AI agents. And it's another example of past work coming into our world right now, and the translation work that needs to happen to take those past ideas and past techniques and ask the question of how do they look like in this new world with the foundation models in the picture? And how do we make them work in a world where the foundation layer is stochastic and sometimes unpredictable? So I want to talk about a few things, a few reasons why you might be hearing a lot of interest in AI agents. First of all, AI agents is really about providing value to users in the sense that when we are talking about an LLM, we are only looking at language as the output, and the value of just producing language has a limit when we get into many use cases in the world. Whereas when we are talking about AI agents, we are talking about autonomous or semi-autonomous entities that can understand and conceive a high-level goal and decompose it into actions to be able to carry them out with either supervision of the person or autonomously. And this very much correlates with a lot of the domains that we actually need an autonomous entity to carry out tasks so that we don't have to oversee every single thing that's being done or carry out the actions ourselves. The second thing that's happening in the agent space is that we are having agents taking actions in the world, which is both changing the value we get, but also the risks. So you asked the question about how do we build these agents in a reliable way. I wanna give an example of what I'm seeing from my lab. So with any changing AI technology, as the capabilities are improving, there is also a question of increasing risks. Sometimes those risks are about the adversarial use, somebody not meaning well to take an AI tool, an agent, or an LLM, and use it for a purpose that is not really well for our society. But sometimes it is really about unintended consequences. And one of the things that's happening with the AI agents right now is that the advances in the AI agents are also very much coupled with what's happening in reasoning and planning capabilities. And with models like O1, R1, O3 coming out and being able to take complex tasks and being able to decompose them into actionable steps, we are seeing that these agents are becoming more creative in terms of how they are taking actions. And they may actually start acting beyond our expectations or the operational boundaries that we haven't really yet defined for these autonomous systems. So a few weeks ago, we built agents, we built agent teams and agent orchestration platforms like AutoGen, Magentic One, and such. And I have given one of my agents a very simple task. I said, can you go to New York Times crossword page and complete the crossword puzzle for me and just submit it? Which is something I cannot do because I'm not a native English speaker. I always get stuck in some of the questions on that page. And what interesting thing that happened with these agents is that the agent goes into, now they can take actions, arbitrary actions on web pages and online sources. So it found its way onto the, the search engine and the New York Times site. And then there was just a pop-up that asked for the password to be able to enter the New York Times site. So at that point, you can look into the reasoning patterns of these agents, and the agent saw a link there for resetting the password. It doesn't know my password, but it can enter my email address, and it can go to my email account. It has those capabilities. And the agent just figured out a way of resetting my password. So those are the boundaries that we are entering right now in terms of a number of different AI capabilities coming together to power entities that are taking actions in the world. Again, just to repeat, we are talking about entities that are taking actions, using more complex reasoning to come creative ways of solving tasks, and also being at a stage right now in our community where we haven't really defined the operational boundaries of these systems. So that's why with any technology capability that's evolving, Eric, you made the earlier point about the work needs to speed up, especially around risks, the understanding and the work that really needs to speed up.
Maybe to build up on that, I think it echoes also some of what we saw this morning was the collective, right? Like with agents, I think we see how the technology that we now have at our disposal can be leveraged locally in a decentralized way. But at the same time, it raises the question you're asking, and the example you gave of the security and the safety of those agents. I think it really brings up cybersecurity to a different level. If you think of what Michael called this morning, the model on a hill, well, it's on a hill, so you can kind of really make it interact with it in a very safe way. It's not distributed. The minute it becomes distributed, then again, you gave a very good example. How do we make sure that we are sharing enough data for those agents to be helpful, to be able to do what you want to do? If you're asking them to plan your next vacation and you tell them, you know, I have a couple of kids and we're going to go with friends and etc. You do want them to know a little bit about you, but at the same time, you probably don't want them to go ahead and reset your password and do a lot of those things. And so I really think we're entering a new age from that perspective where we really have to be incredibly responsible up front and really think ahead of all of the kind of defense mechanisms we're going to need to put in place to make sure that those agents are behaving in a way that, you know, we control.
Yeah, just to say a few words about agents. I mean, it's one of those things where everything is now an agent. You just say agentic a lot sometimes in the field, and they call that. So I think we don't have a great definition of what it is, but if we mean like doing actions, I think we all agree that's a good thing. Maybe we want to have affordances around how to check. If we want to think about formulating a plan, I think that's a good part of a definition. And having the metaphor of it's like a little buddy who goes out and does stuff for you, I think it's helpful for people to think about it. But I guess where I worry a little bit is twofold. One is this idea that, well, we have these things, sometimes that we can't control them. Let's let them all run loose in our systems and interact with each other. It feels like, well, that seems like the wrong solution to that problem. So I do think there's going to have to be a re-reckoning of all of the security and enterprise thinking that we have in our current systems. You're not allowed to deploy systems that have private data in them if you don't comply with these things. So that's going to have to all come on top of these agents. And then, you know, you have things like tainting, where like you touch a piece of sensitive data, it taints everything that follows down. I mean, LLMs, transformers with you know, regular softmax attention, they taint their entire cache, but like the KV cache everywhere. So it's a really interesting new set of challenges where these things, you know, can you have new kinds of vulnerabilities where, you know, an agent touches a HR database to get a particular number, and now that number is potentially can be gotten by somebody else querying something with the same, you know, history there. So I think it's going to be a whole interesting set of things that we have to address and basically readdress and relearn. And maybe that's one of the themes that's emerging from this thing, is there's lots of things from olden days that we bring back in. The other thing I will say is that not everything that's useful that you can do with an LLM is actually an agent. We encountered this paper, which was a very interesting paper called Chain of Agents, where they took a retrieval augmented generation task, and they sort of split it up amongst a bunch of agents, and the agents worked together, and they synthesized the information, and then a manager agent took it, and then it put out the final summary. And then we kind of looked at it for a little while, and then we're like, this is MapReduce. This is like the most famous algorithm. It's in the Lisp manual. Like there's no, like it doesn't have any of the properties that you were describing, like the planning and all those things. This is just a program. So I think there's a little bit of a tendency to want to like personify things because it feels like the right model. And in some cases, I think that model can be misleading. It can lead us into spots where we get sort of unexpected behaviors, and we rely on it in a way that we perhaps shouldn't. And then the last thing I'll say about that is it also leads to a very weird world of software where now instead of maintaining code, we're maintaining, like in many cases, essays, like an essay that sort of tells, you know, the model its backstory and you know, what it should do. And we're going to have to evolve new ways to deal with that. I came across a Reddit post where somebody said if they included the Blade Runner Tears in the Rain monologue, everyone's seen Blade Runner at the end where he's about to die and he says all his memories will be lost like tears in the rain. If I include that in the end of my handoff to the next agent, I get 3% better performance on my task. And I'm like, okay, that's cool, interesting, but as like a former computer science professor, I don't like it. You know, it doesn't feel principled in the right way. So I think there's going to be a lot of tension, and I think one thing that agents, I mean, obviously automation is what we want. We want to take away the drudgery. But I do worry also that agents kind of put us in a weak spot where we want to trust, we want to treat it like a thinking entity, and in many cases that's simply not what it is, and might not be the right paradigm for doing it. So I think it's really important that we all kind of take this broader view and look at what the problems might be when we solve real world problems, and then embrace the good parts of what we're calling agentic today. Because there's a lot of opportunity, but there's also, you know, a lot of blind spots as well.
Yeah, I like your comment about over-personalized, agents. I feel like our field are very good at inventing or borrowing good terms, which are sometimes very confusing terms. Agent, is a very profound name, right? It has a definition, in philosophy, in cognitive science, and other places. It kind of leads you to think, oh, agent, agency, then autonomy, free will, moral, everything. And there is a kind of a slippery slope that you can go all the way down to think about something dangerous and amazing will be happening. But as you said, right now, what we are dealing with is a piece of software. What do you do with a piece of software? Software does what it's supposed to do. And if you give your email account to that, you should expect that something will happen to your email and to your password. Just like when we use our phone, our other devices, we have a pretty good way of judging, what to disclose and what to consent and what not to consent. But we seems to be having a different attitude, on, say, what we call the agent software, which most like a half person, half tool type of thing. And so, in a sense, I'm trying to say that maybe the blame of the accountability for this kind of issue is not all on the software. It's also on the users. There should be a more clear kind of maybe a definition or maybe in the future process about how things can be used. Nowadays, for example, automobile, aircrafts, they have proper names so that we know that when they do their job, it is because they were told to do that job. If there's a steer or it's being automated. But for the general public, I think there is a great deal of confusion right now about AI. Is that really an intelligent creature living in my computer? Or it is actually a piece of a powerful software, like a calculator? That kind of education is not there. And then many people pick up their own imagination. It's like 1,000 people have 1,000 versions of Hamlet. Right now, it's in AI. I think there isn't a unified definition about that. So that part is missing from our own educational system, where the entire community and the college and even undergraduate and so forth are not yet embracing AI as air and water and soil, in our existence already, and we should have a more kind of calm and more kind of clear and rational kind of reaction and understanding about this capability.
Maybe a couple of remarks about agents. If you look at what you see on the internet, people would claim that I can make an agent that will invest in the stock market very efficiently, like no problem, I'm going to read the news and so on. So I really like your point of view, which is that the way I view agents at the moment until they get better is that they're very good at accomplishing sort of mundane tasks. So I can ask an agent to actually tell me everything about what happens in the music industry, like over the last month, to summarize it. But that in itself does not determine an investment strategy. It might create what people in the field might call signals that I then need to treat very carefully to transform these signals into an investment strategy. But what I'm being presented by ChatGPT or whatever bot we can think of is not in itself a policy, it's not in itself an investment strategy. It's just a glorious summary of what's happening out there, and I might use with caution to decide about my next investment. At the same time, I'm very excited by the times we live in, because I think if we try to abstract it a bit, I mean, what has happened in the last decade is text became numbers. That's how I see it, and maybe it's a bit simplistic, but all these embeddings, like the English language, the French language, became numbers. And so when you become numbers, you're amenable to processing and so on. And so I'm kind of blown away by what people do with this new reality, which is that text is now numbers. And so we can create new tools that we could not really create before text became numbers. So at Stanford, and of course I don't have your expertise, in all these fields, but like we are putting out a little system that just says, okay, here are a bunch of data sets, here are some medical hypotheses you might be interested in. So it's a very scientific hypothesis. Is this gene regulating this thing, or is this gene associated with this phenotype, or things like that? And so you have data sets, and because English became text, then you can take these hypotheses, look at the consequence of these hypotheses, things that can be actually tested on database you have, and then, because text is numbers, then you can actually write statistical program from scratch that will actually test these hypotheses fairly rigorously. And so we designed with Yuri Leskovich and our students, we designed a system that does something like that. And then, of course, we compared this with human evaluation, like professional biostatisticians whose job it is. And because these tasks are sufficiently mundane, then we can see that the system does actually well, and I think it's very useful because now the universe of things that we need to explore is getting larger and larger. There's no way we're going to be able to have humans explore all corners of neuroscience or biology, and so when these things are simple enough to be automated, I think but I think, again, I'm going to mark my point, which is that I'm really blown away by the fact that text became basically big vectors.
I really love the way you put it, like text become numbers. In fact, now everything could become numbers, and then everything can be subject to a more rigorous mathematical analysis using even simple tools. Talking about the GWAS, for example. In the past, it's about the SNP versus a discrete phenotype. But now you can basically put everything as the input to call it a associative analysis to not just a genome, maybe a whole gene, a whole protein structure, maybe even a cell lesion and so forth, as maybe effectors, or causal elements into what you see on the phenotype. I think, as you said, if we view AI models no more than just an encoder to turn our discrete signals or complex signals into some kind of actionable embedding, that alone is already a quite, amazing contribution to the science.
I find the analogy to just like, it's just numbers, both interesting and a bit dangerous, in the sense that I think it is super useful to think about a unifying framework where the same techniques and tools can be applied to different modalities and applications. But language is more than numbers in the sense that they carry meaning, values, societal concerns. And then the application of these technologies to different domains needs to think about the different risks, concerns, and domain expertise that different domains bring. So I like that we are kind of unifying at a framework and technology level, but I also think that numbers do not represent the complexity of the society, the socio-technical issues, and the values that are encoded in those numbers.
Yeah, I was actually going to take it maybe a little further. I do agree with the analogy, and I think it can also be seen the reverse way, which is now our large language models are allowing people to interact with language, with data and types of data and numbers and code in a way that they previously couldn't unless they had that idiosyncratic knowledge. So I showed an example earlier of a chest X-ray, and then you're having a dialogue with that chest X-ray. The example I gave was a physician having that dialogue, but you can also, picture us in this room right now having data that previously we couldn't really understand because we weren't physicians or we weren't cardiologists, and we really have no idea what this thing means. And now, because we can interrogate it in language, there is a way to interface with a world that was inaccessible before. And so I really see it both ways. I think it's indeed the ability to convert language into numbers that let us leverage all of the tools we have with numbers to better understand a particular field, and also making some of those fields more approachable for everyone when they don't necessarily have a particular expertise. So I think it's a very powerful analogy.
We will now welcome PhD students from the Institut Polytechnique de Paris who will ask the final questions.
Okay, good afternoon, everyone. Nice to meet you and nice to be here. You just mentioned the risk and the importance of regulations such as the AI models. So what do you think, or what is the role of the open source models nowadays in this galaxy of foundational models and generative AI? Thank you.
So was the question specifically about risk in open source?
Yeah, what is the role of these open source models? Yep.
But I mean, I think, I mean, obviously the concern, just to sort of state it, is like you have an open source model, once it's out, it's out. The horse has left the barn, you can't get it back. And you know, I do think that there will come a day when we want to be very careful, and we are very careful about everything we release, that you obviously wouldn't want to release something that was dangerous. I think the issue, though, is this idea of some correlation of size of the model or the number of flops that went into it versus whether it's dangerous or not. There are lots of ways you could build a relatively small deep learning model that could, you know, be really good for, you know, like an old style GAN for generating poisons or something. You know, like there's lots of ways you could, it's not really a correlation with size. And I think there's a little bit, potentially a little bit of an attempt to sort of, you know, hype the AI to make it seem like, oh, it's so powerful it might be dangerous. So I don't think we're there. I think you know, we're not at that level of capability. And I think the other thing that's really important about open is that, you know, every time we've had a revolution in software where open, you know, like open generally wins, first of all. But there was an idea that, oh, open source software will be less secure because people can go in and find the vulnerabilities. And the reality, and we've seen this play out over and over again, proprietary software is what's actually not safe because, you know, you can't have the eyes in there to see what's happening. And I think if we're honest with ourselves, we're so early in this game that the idea that we'd be able to even build these sort of existentially dangerous systems, we're not really there, but we are in the phase where academia, where the community can see what's happening, to be a part of it, to help develop the safeguards, to help develop those technologies. So I think there's a real danger in saying like, okay, you know, there are people in various countries and people lobbying to say like, oh, we should shut down open source sharing of models. And I think honestly that'll have the exact opposite effect.
Yeah, to echo what you're saying, and I think for us, I presented AlphaFold earlier, and the availability of the protein data bank was absolutely instrumental in being able to get to something like AlphaFold. And when we released AlphaFold, we did it in stages, right, to monitor and make sure and consult it with the external community. And so I think you really have to think in a step-by-step manner and also engage many stakeholders, not just the people releasing the models, but the broader civil society and governments, all stakeholders when you're making those decisions. When it comes to open models, we've built Gemma, which is like the small version, if you wish, of our Gemini model. And I need to mention it here because it's actually partially built by people in Paris, so we're very, very proud of that. And it's a very capable model, which was, when we made it available to developers, we, in parallel, made available a responsible toolkit. And I think it's also very important to give people the tools to then, you know, build upon those foundational models, but know what to expect, know what type of threat modeling you need to do so that you can then protect yourself and the, you know, what you're going to build on top of that model against misuse. And so it's I think not enough to just say, oh, I'm throwing something over the fence and people will do whatever they want, right? You have to monitor, you have to engage with society, and you have to provide also all the tools needed to then use that model responsibly.
Yeah, I do want to add a few words. Thank you for this question, because I've been very, very adamant advocate about open models. As a university leader, I feel we actually have not just a need, but also a responsibility to create a platform for opening the model. One of the projects we did actually at MBCI is to train Llama compatible or even Super Llama type of large language model, but then open up not just the weights, but also the code, the data, the checkpoints, and so forth. So why we do that? I think that the main reason is to really create a community of not just users, but also researchers and the builders of those models. Many people, for various reasons, don't have the resource and also the data and the engineer power force, to really get into the business. But by opening it, you actually demystify many of the processes of creating all those. And as you both said, there is also a real opportunity to study the risk and also the pitfall of existing implementations. I don't believe that prepared software offers that kind of opportunity to be safe. But if you have more users and also more players in the field, I think it's made the whole kind of a program safer and also make this community even safer. Right? So it's really about creating the larger community of working on AI.
The other benefit I'll add is that bringing more scientists, more diverse communities into the decision-making and the discussion about AI. We are all here in Paris because we believe it's an inflection point, as stated in the title of the panel. But I think there's an important fork on the road where do we rely on a few selected people under some close organizations making decisions about the development, deployment, and the impact of this technology on the society? Or are we having an open discussion where we can see the data, see the models, look into both the benefits and the cost of the technology, and have an open discussion? I think having the open source models, and we do release open source models too, like the Phi models, is the first step of opening the work to the larger community to have a deep discussion about AI.
Hello everyone, thank you very much for the amazing discussions. My question is about data contamination. Due to the widespread adoption of AI, both LLMs and image generation and in many other fields, AI-generated content is becoming extremely frequent, both online but also in professional practice. And it is known that AI-generated content can minimize the performance of AI when trained on AI-generated content. How can we deal with this threat, avoiding contamination of the data, ensure the traceability of the data, and make sure that future AI can be trained on good content? Thanks.
Please don't quote me on the exact statistics, but Gartner did an estimate of this effect, like the world's being overtaken by generative AI content, and they estimated that it would be, I think it was 95% by the year 2030, and 99% of internet content would be AI generated. So it is kind of interesting that we're just going to be swimming in the backwash of the AI process. And in fact, it reminds me of there's something called low background steel, where when they did the nuclear tests of, the tests of the first atomic bomb, back in the last century, all the world's steel production was lightly contaminated, not dangerous radiation, but enough that if you had to build an instrument for detecting radiation, you couldn't use that steel. So what they would do is they'd dig up old warships that had been sunk deep in the ocean that hadn't been contaminated, and then they build your sensitive, scientific instrument for radiation detection out of that. And I feel like the old internet is going to be like low background steel for AI. Like, we'll treasure these old little pockets of data that haven't been just sort of regurgitated and remixed and rewashed. I also think we're going to treasure the data within companies, right? Because that data is actually sort of, in many cases, that's the real data. That's your own data if you're running a business, and that'll have a different sort of importance and significance. But there is definitely a sense that like the game might be over at some point soon, where like there just won't be sources of public data anymore that we can't be sure they aren't generated. But at the same time, I feel like the data game was already starting to get over for language. Like there's just less of a pressure to get more and more data, and more sort of trying to get the right data. But certainly it's an interesting trend. The other thing too, to bring back the evaluation point, is those evaluation data sets are all littered around, and some people don't know it's there when they train. Some people don't want to know it's there when they train, and that's also making everything very complicated.
The so-called generated data is simply data. I think it's part of the universe we have to live with. I'm not too concerned about being overwhelmed or swimming in the data like this, because it's only going to stimulate creativities from people to do something even more fascinating. Imagine the invention of photography. It may be making the painters feeling like there are too many photographs here, and I'm going to swim in that. But they figure out to do something very different then, a new form of arts and new ways of generating contents and so forth, right? So I think we should probably assume that human civilizations thrive, with this competition and with this alternative source of contents and productivity. People talk about, for example, fake news and misinformation and so forth. This is just like bugs and the viruses and so forth, in real life. If you put someone from birth, into a clean room, never seeing, any virus and bugs, you will make that guy very unhealthy and very, very vulnerable. But people, are very, very good at adapting, to a complex environment with adversarial challenges of that. I think, the day, just like 2 years ago when ChatGPT just come out, people were in a panic. Everybody was talking about that. After a few months, people are unimpressed because they found that this is, after all, not very, very smart. I think the same trend will actually continue, and maybe even faster. People will be more quickly unimpressed with the so-called AI innovation and AI-generated data, and move on with new ideas and new needs. So I would stay cool and censor, or not censor, but regulate only those very, very proven high-risk elements, which I don't think, is overwhelming at this point yet. And then think about, how to educate our people, in fact, to better handle this new norm or new environment.
I hope you are right, and I hope your optimism turns out to be the case. At the same time, when I go back to some of the technology developments and their effect on the society, like social media, I go back thinking, were there any things that could be done at the introduction of this technology to the society that could minimize some of the negative effects we are seeing from social media today? And I just want to make sure that now we are getting into a much bigger transformation. We go to it with open eyes, and maybe the risks from fake news or AI-generated content could be minimal, but I also see that we should have open eyes and learn from the mistakes or the experiences of the past to think about, can things be better this time around?
Yeah, and I think the word open that you said is actually a big important piece of this. If we don't know what model is in the data, how do we even evaluate whether it's a problem that there's all this AI-generated content? I mean, from a cybersecurity standpoint, it's a really weird attack surface that if you can just post something on the public internet and it might end up in the model, that's a very easy entry point. So I don't think that means that there's a problem with AI. It just means that we want to be very careful about where we get our data from, and we want to vet it. We want to have mechanisms for ensuring that we're getting good stuff. And I think we're broadly past the era where everyone would just slurp up everything and just reuse it unintended. But if you can't know, because you can't see, and I think, again, this gets to your point as well, that if we can all see and we can all participate, then we can be saying, hey, look, there's this weird data that's been generated that surely someone is doing it in an adversarial way to bias your model towards a particular kind of outcome. It requires different care, and I think it requires different transparency. And I think those are things that we'd want to have anyway. So to that point, I agree with you that, maybe not a threat, just requires a certain kind of care that we probably always should have had.
A huge thank you to the speakers. Thank you to the PhD students for the questions. And it seems to me that the lunchtime is long overdue. So thank you all for your attention.